I'm just... Oh, yes, guys. Very, very good evening, everyone. And finally, the GATE 2025 EC paper is also conducted. And yes, the entire team of OM is going to be live in front of you. And we have got some questions and we are collecting more questions. And by the time, let's discuss about, some questions that I have got from signals and mathematics. And Shankar sir will soon join for control systems questions, and Gautam sir, Hemant sir, everybody will be joining. So first of all, guys, you can also let us know how did you feel about the paper, how the paper was, because what are the updates that we have got till now. I have the complete weightage analysis. We'll talk about that. Okay, communication and EDC, the two core subjects, are on the higher side, but at the same time, EMTL having a very low weightage. Okay, and unusually, if you look into the especially past 4 to 5 years pattern, digital, of course, having a higher weightage. But the thing is, EDC analog, which the students usually worry about, and this has been very, very easy. Okay, this time, especially EDC, like last year, EDC was a bit tricky, but this year, EDC, what is the updates we are getting is slightly, relatively, quite easier. Okay, so yes, dear, quickly keep on joining the session and do share the session with all your friends. All right, guys. Okay, so let's start with the basic weightage analysis. Okay, the data that we have got. And one more update that, around 8 to 10 MSQs. This is a big number, mostly easier side and mostly property or, simple analysis based. Okay, but yeah, around 8 to 10 MSQs were there in the examination. Around 8 to 10 MSQs were there in the examination. So yes, guys, come up here. Let's first of all start with the weightage analysis. Let's first of all get started with the weightage analysis of the paper. Okay, so starting with communication, having a very high weightage. Okay, so I'll write down the complete data. So communication, 4 questions, 1 marks, and 6 question of 2 marks, making it total of 16. Okay, very high. Okay, I mean, some questions are there from probability and random variable part. Okay, so that you can put it in communication or maths, any of the area. But yeah, communication separately, there are some probability questions where they're simply asking the entropy. Okay, so a total 16 marks. EDC, 2 questions of 1 mark and 5 questions of 2 marks. So 12. EDC also slightly on the higher side. Control system, 2 questions of 1 mark and 3 questions of 2 mark, making it 8 marks. Almost expected. 8 to 9 is what you expect from control system. Signal and system, 3 questions of 1 mark and 2 questions of 2 marks, making it 7 marks. So slightly on lower side, because normally you are expecting 9 to 10 marks of signals. But nevertheless, some questions of signals could be mixed with communication. We'll have a look into the questions again. Mathematics, 5 plus 4 pattern again. So 5 1 mark, 4 2 marks, 13 marks. This is what normally is expected from mathematics. Coming to network again on the slightly lower side, 2 and 2. Okay, that is total 6 marks. Okay, analog circuits, 4 and 3. Okay, so that makes it 9 marks. Fine, fair enough. Okay, that makes it 10 marks. Okay, coming to digital, 3 questions of 1 mark and 2 questions of 2 marks, and that is 7. EMTL, as I mentioned, is slightly on the lower weightage as compared to the previous 4-5 years. There is no question of 1 mark and there are 3 questions of 2 marks, total 6 marks. Okay, total it is 6 marks, and GA to you all know 5 questions 1 mark, 5 questions 2 marks, 15 as always, and all GA questions MCQs, that also is expected as we know. Okay, so this is what is the weightage distribution that we have got here. This is what is the weightage distribution that has been obtained. Okay, dear, so already a poll also has been created. And you can also let us know your opinion in the poll, how the paper was. Okay, majority of the students till now say it's moderate. Okay, yeah, that's what, easy to moderate, different opinions. Even few say difficult also. But if you see, with the direct interaction also, this is what is the updates I have got it. Okay, and yeah. So Gautam sir is on the call. Let me also pick up the call because Gautam sir is straight, live from the exam center. Hello. Hello. Sir, we are live into the session and students are listening your voice. So what is your opinion about the paper?
Paper is definitely not difficult, sir.
Okay, not difficult means moderate side, more or less.
I would say it is in between easy and moderate.
Correct. Yeah, some similar updates I got from Hemant sir. Which one, sir?
Many questions are dead easy. Like, just look at the question, put one formula, get the answer.
Yeah, correct. That is what, even the questions of signals and maths that I have got till now mostly looks like easier side only. Yeah.
EDC questions, I can confidently tell that these are the easiest questions in the history of GATE.
Oh, easiest in the history of GATE. Because last year EDC, I remember, was little tricky, if I say last year.
Which one, sir?
Last year EDC was more tricky, but this year you are telling it is very easy.
That's one. Hey, forget about tricky. At least one or two good questions will be there.
Correct.
Even that is not there.
Okay.
You don't have to do anything. Just look at the question and you can put the answer.
Correct. And weightage is also good. 12 marks of weightage. Okay.
Communication has got highest weightage.
Yeah, communication 16 marks.
16 marks.
Yeah, that's great. So those who prepared these subjects.
Aptitude also. Yeah.
Yes, sir.
Aptitude questions are actually easy.
Okay.
But you need patience.
Patience, maybe lengthy. That is what sometimes happen in aptitude. Questions look like very lengthy. Okay. Fine. Right. And sir, how many MSQs approximately? Any idea we have?
Plenty of MSQs. I didn't calculate.
Yeah, I've got to know from Hemant sir that it is roughly 8 to 10 MSQs that has come up.
Yeah, good number of MSQs. I mean, decent number of NITs also. Aptitude, all questions are MCQ.
Aptitude, as expected, all questions are MCQ.
MCQ.
Okay,
Overall,
okay.
it's an easy paper, sir.
Overall easy. Yeah, yeah. One student is also telling
it's an
Pavan
easy
that
paper.
EDC was very, very easy. Yeah, yeah, yeah. So
Analog also.
analog also. Correct, correct,
Analog
correct.
also very easy.
Hmm,
Very
hmm.
easy.
And in through some students, I got to know, sir, controls little tricky. Is it correct? I have not seen the questions as of now. Control, but
When control systems, maybe one or two questions are little tricky.
okay.
Other than that, they are straightforward only.
Okay, okay, okay. So fine, sir. Thank you for your updates and inputs. So, sir, in how much time can we expect you
I'll
here?
join you very shortly.
Okay,
10 minutes I'll join you.
10 minutes. Okay, okay, sir. Okay, sir. I'll continue
sir.
by the
Thank you.
time. Yeah, yeah.
Yeah.
Okay, students. So, as you told, Gautam sir is going to join us very, very quickly. Okay, so by the time, yeah, a few questions that I have, let's get started. Okay, so, yeah, so roughly if I say 75% of the students till now have voted that it is, easy and moderate. Okay, mostly moderate. Some say easy also. So, easy to moderate. That is what is the level we can say for this particular paper. Okay, yes, dear. Now, okay, Pavan says controls was tricky. Okay, we'll come up with controls also. Don't worry. We'll come up with controls. So let me start with few questions that I have. Okay. Here it is. Okay, easy question from mathematics. Easy question from mathematics. So yes, it's a 1 marker and a MCQ questions. I'll write down the question here directly. Okay, so given the matrix A, okay, given the matrix A, a 4 cross 4 matrix has been given, but not to worry, it is easy as far as I look into the question. 2, 3, 4, 5, 0, 6, 7, 8, 0, 0, alpha, beta. Good part is the matrix is already given to you in the row echelon form. Okay, 0, 0, gamma. Okay, the good part is, although it is 4 cross 4, upper triangular, or primarily what is important for us the echelon form, so it is already in the row echelon form. Correct. Now, for which one the rank of A is at least 3. Okay, okay. Choose correct option, something like that. The question is something like that. Choose the correct option. I'll write down the options. For rank of A, okay, at least 3, greater than equal to 3. Greater than equal to 3. Even 3 is included here. So option number A is alpha equal to 0 and beta equals gamma. Okay, beta equals gamma, but both not equal to 0. Fine. Option number B says that alpha equal to beta equal to gamma equal to 0. Option number C. Oh, where is the option number C? Here it is. Option number C, beta equal to gamma equal to 0 and alpha not equal to 0. And option number D says that alpha equal to beta equal to gamma not equal to 0. Okay, right. These are the 4 options. These are the 4 options. Okay, for which of them the rank is at least 3. The rank is greater than equal to 3. Okay. For which one? And then there are, sorry, these are the 4 statements given and then there are the 4 options actually for which of the condition 1, 3 and 4. It's a MCQ question as I've mentioned. It is not a MSQ one. Okay. B option says only 1, C option says 4 and D option says only 2. Okay. And these are 4 different conditions. 1, 2, 3, 4. Okay. So dear, it's a basically simple question you would say. See, because it's row echelon form, the rank is equal to number of non-zero rows. We can directly say that. And the first 2 rows are clearly non-zero. The first 2 rows are clearly non-zero. Okay, so we need to talk about the third and fourth. Okay, so now dear, first option, alpha 0, beta and gamma both equal and not, it's not necessary they must be equal. Okay, but yeah, beta and gamma not equal to 0. If beta and gamma both not equal to 0, then what you can say? Okay, then what you can say? Beta and gamma then not equal to 0, but alpha 0. So see dear, alpha equal to 0, that means now even, I'll write it like this. Okay, this is 0, beta and gamma equal. Okay, so this also will become beta. Okay, this also will become beta. Okay, so even if you want to apply row transformation R4 minus R1, this will become 0, this will still be non-zero. Okay, so rank will be 3. So under this condition, I'll write down the rank of the matrix under this condition is 100% 3. Is 100% 3. Okay, next condition, alpha, beta, gamma, all 0. Say if all zeros, the rank will become 2. So that is what I don't want. I want rank at least 3. Okay, so under option, under statement number 2, rank will become 2. Okay, beta and gamma 0, alpha not equal to 0. This is 0, this is 0. This is 0 means fourth row 0, but third row, okay, third row is non-zero. Okay, and if third row is non-zero, rank will still be 3. Okay, rank will still be 3. Rank will still be 3. Alpha, beta, gamma, all non-zero. So if all non-zero, then the rank of the matrix will actually become full. Okay, so we want rank greater than equal to 3. So first, third and fourth. Option number A, dear. First, third and fourth. Is that clear, everybody? First, third and fourth. First, third and fourth. Right, dear. Okay. Yes, first, third and fourth. Correct, Pawan. Correct answer. Okay, FIFA shots. Manikanta, you says aptitude all that. Thank you. Okay, go. Okay, congratulations. Great. Okay, guys. Now next question. Okay, next question again. Yeah, let's take it from mathematics. A very simple question from probability. Okay, a very simple question from probability. 1 mark MCQ. Okay, a pot has. The question is, what is that? A pot has 2 red balls. 2 red balls, 2 blue balls. I would say one of the easiest question of probability. Usually doesn't come up that easy for EC, guys. Okay. 2 red balls, 2 blue balls. Okay, 2 balls are drawn randomly. 2 balls are drawn randomly. 2 balls are drawn randomly. Okay, fine. What is the probability that what is the probability that the 2 balls have different colors? The 2 balls have different colors. Okay, option number A 1 by 3, option number B 2 by 3, option number C 1, option number D 1 by 2. Okay, dear. Yes, tell me, did you get the answer for this? Tell me, did you get the answer for this? Okay, so dear, very, very simple question. Okay, 2 balls are drawn. What is the probability that both the balls have different colors? Both the balls have different color means 1 red, 1 blue. So you can make the cases and solve, or you can directly solve it using the combinations. Okay, 1 red ball, selecting 1 red ball, 2C1. Selecting 1 blue ball out of 2, and there are 2 blue balls, so 2C1. Okay, divided by the total cases, favorable upon total, and total is 4C2 cases, any 2 balls out of 4. Okay, any 2 balls out of 4. Okay, so this is 2 into 2 divided by 4C2, which is 4 into 3 divided by 1 into 2. So it becomes 8 by 12 and 2 by 3. Answer should be 2 by 3. Okay, Pavan, please check it. Answer has to be 2 by 3. Direct. Okay. No. Pavan and HD Sport, you say A. No, it has to be 2 by 3. Okay. Or even if you have solved by cases, na, suppose if by chance you have solved by cases, then how you should be solving? If you have solved by making cases, okay, what is the probability that 2 balls have different colors? No, SD Sports. Different colors, but what is the 2 balls have the different colors? Okay, so then it could be this case, na? Red and blue. If you are taking case by case, blue, red, red, blue, blue, red, red, blue, or blue, red. There has to be 2 cases. Okay, if you are taking case by case, okay, 2 by 4 into 2 by 3, and same result for the next one. Same result for the next one. Okay, so in either of the case, it is 8 by 12, dear. 4 plus 4. Either of the case, it is 8 by 12. Yes. Yeah. Because, either if you draw 2 balls together or if you draw without replacement, it is one and the same thing. That we know that balls are drawn without replacement or all at a time is the same thing. Replacement not there, na? That is what? Replacement not there. That is why I have taken 2 by 3. That is correct. Balls are drawn without replacement. 2 balls are drawn without replacement. Even if you go, if they mention 2 balls are drawn without replacement, so that is what you will do now, 1 by 1. But what is the first ball? They told only 2 balls of different colors. They did not say first has to be red or first has to be blue. Now 2 cases will come. Is that clear now, Sanjay, HD Sport and Pavan? Okay, so 2 cases will come. Okay, if they mentioned probability that first red and second blue, then answer will be 1 by 3. Okay, so yeah, confirm me, is this okay now? Okay, if this is what was the question, two balls are drawn randomly without replacement, you are telling. Okay, okay, correct. So then answer has to be B only, dear. Answer has to be B only. Moving ahead to the next question, dear. Moving ahead to the next question. Hope that is clear to all students now. So guys, I believe that was one of the easiest question of probability, but I think it has got some students into the trap. Okay, because usually for EC you will not find that easy questions of probability. But nevertheless, it happens, no problem. Let's go to the next question. Okay, a calculus question, 1 mark MCQ. There is a question from, it's MSQ actually. It's MSQ. Okay, a function has been given to you and that is 2x cube minus 3x square minus 12x and plus 1. Okay, identify the correct statements. Okay, option number A, x equal to minus 1. Okay, x equal to minus 1 is local minima. Option number B, okay, the function f has no global maxima. Okay, no global maxima. Okay, x equal to 2 is global or local? Can you confirm? I think I'm able to read it as a local maxima. It has to be local only. The global anyways will not be correct here. Okay, it is a local maxima, and option number D says that f has no global minima. F has no global minima. Okay, this is what is the next question. Okay, okay, fine. So dear, tell me, MSQ question, what is the correct answer you have done for this? Yes. Okay, so yeah, now I think students are clear with the previous question. HD Sport and Sanjay, fine. So have a look into this, dear. Okay, if I just take the stationary points, okay, if I just take the stationary points by taking the first derivative, so it should be 6x square minus 6x minus 12 equal to 0. Or if I remove the 6, so x square minus x minus 2 equal to 0. I think it can be factorized simply x minus 2 and x plus 1 equal to 0. So we have the stationary points in the increasing order as minus 1 and plus 2. Clear, everybody? Okay, now if I simply apply the wavy curve method and the first derivative rule, okay, the stationary points are minus 1 and plus 2, and the wavy curve starts from the right of largest root with the plus sign and it keeps on changing the sign, minus and plus. Okay. Okay, this is the wavy curve for f dash. Okay, so that means function is increasing. Wherever first derivative positive means increasing function, then decreasing, then increasing. Okay, so minus 1 should be what point here? Okay, sorry, let me take it this way. Minus 1 and 2, whatever the value of the function. Okay, randomly let me assume any value. No need to calculate this, but up to the minus 1, first derivative positive, the function is increasing, then it is decreasing, and then it is increasing. Something like this, the curve will come. So minus 1 should be a local maxima. So option number A is wrong. 2 is a local minima. Okay, so option number C is also wrong. Okay, now f. Okay, because there is no boundary given, function can range from minus infinity to infinity. So there cannot be global maxima or global minima. Option number B and D correct. Okay. If the function is taken polynomial function, it is from minus infinity to infinity. So global minima is also undefined, minus infinity, global maxima is also undefined. Okay. So correct answer is B and D. Okay. Pawan, please recheck. You are telling opposite, not A and C. A and C are wrong actually. Okay. A and C are wrong. They have given different. You just confirm me whether these were the options. Okay. Minus 1 they say local minima, whereas minus 1 is the local maxima point. Okay. Pawan says it was reverse. Okay. So if it is reverse also, then also Pawan, B and D is correct. B and D is still correct. F has no global maxima, no global minima if there is no range given for the function. If there is no domain given, I mean. If there is no, values of x specified here. Okay, as if this is the question, then A and C are wrong. This is what is the question I've got. Okay, Teert say this one was correct. Okay, then if this is correct, dear, B and D is the correct option. Okay, then we'll go with B and D only. Fine. Okay, chalo, next question, dear. If this is correct, no problem. Even if it is varying, it is memory based. Doesn't matter. Okay. Now, okay. So here I have a question of differential equation coming up. The previous one was also, I'll mention it. 1 mark MSQ. Yeah, I mentioned it. Okay. The next question is here. Okay. This is 1 mark NAT. Okay. And there is a differential equation given. T square y double dash T. Okay, minus 2t y dash t plus 2 yt equal to 0, given some initial conditions, y dash 0 equal to 1 and y dash 1 is equal to minus 1. What is the maximum value of yt? Maximum value of yt over 0 comma 1. Maximum value of yt over 0 comma 1. Okay, so t square y double dash and t y double dash, Euler-Cauchy differential equation, dear. It is a Euler-Cauchy differential equation, correct, dear? We can say that it is a Euler-Cauchy differential equation. Okay, it is a Euler-Cauchy differential equation. Okay, this is what I've got in Clee's handwriting. Done, sir. Almost these are done. Only one is left. Okay, I'll keep it. Only one question is left out of it. Okay, yeah. So, dear, okay, Sasi Ram says minus 1 is a local maximum option. Whatever, dear. See, I have told you, you see this graph, na, enough, na? Okay, this is local maxima. I'll mark it like this. Okay, okay. Then this point becomes local maxima. This point becomes local minima. Okay, this is memory based. Even options are different. Then you know what is correct, what is not correct. Now, we have discussed. Okay, we have discussed. Okay, so let's not create that confusion. Now, what is this differential equation given, dear? It's a Euler-Cauchy differential equation, isn't it? Okay, it is a Euler-Cauchy differential equation. Y is a function of t and t square multiplied by second derivative, t multiplied by first derivative. See, that is why, you know, we keep suggesting you to solve for mathematics PYQs of all branches. In mechanical, the paper which was conducted in first weekend, a very similar question of Euler-Cauchy was there. Anyways, chalo, it's the same model. That's why I'm telling you. Okay, now let us come to solving it. Okay, so you know what do we do in Euler-Cauchy? Okay, what do we do in Euler-Cauchy? Okay, what do we do in the Euler-Cauchy? Okay, so normally you might be remembering the substitution x equal to e power t, okay, where y was a function of x. Only thing is here y is directly a function of t. So let us put t equal to some e power u, no problem, na? Let us put some t equal to e power u. Okay, now if it is a second derivative, how the differential equation will be converted? D minus 1. Okay, so what will be my d here? Okay, what will be my d here? Derivative with u now. Okay, let's make y as a function of t and t is a function of 2, y is a function of u directly. Okay, so d minus 1, okay, into y, okay, minus 2 t into y dash will becomes dy and plus 2y equal to 0. Okay, so d square minus d minus 2d, so minus 3d and plus 2 into y equal to 0. Correct, dear? Okay, so first of all, note that there is no forcing function, so pi is going to be 0. Only thing you have to find is the complementary function, which can be solved by auxiliary equation. Auxiliary equation is also simple. M square minus 3m plus 2 equal to 0. The roots are m equal to 1 and 2, okay, which are real and distinct, real and different roots. So what is the yc? The yc will be equal to, okay, c1 e raised to the power m1 t, m1 u, it's a function of u, c1 e power u, c2 e power 2u, correct? And as I told you, the total solution will be actually yc plus yp. The total solution yp part is 0, so only yc and c1 e power u plus c2 e power 2u. But remember, dear, e power u is equal to t. Don't forget that. Okay, what is the e power u? That is equal to t. Okay, so what is the y? c1 into t, c2 into t square. And what is the initial condition? I think one initial condition is given for y dash. Okay, what is y dash? No problem. Let me first put down the initial value given. Y both are for y dash. Let me confirm. Okay, both the initial conditions are given for y dash. Y dash 0 equal to 1 and y dash 1 equal to minus 1. Okay, so yeah, better to differentiate. Y dash is c1 plus 2 c2t. It is more simple than c1 plus 2 c2t. Okay, now y dash 0 is equal to 1. Y dash 0 is now equal to the 1. Okay, so what is the y dash 0 is equal to 1? Correct. Okay, so 1 is equal to c1, t is 0. Okay, so c1 is 1. Okay, and then y dash 1 is equal to minus 1. Y dash 1 equal to minus 1. That is the next condition given. Y dash 1 equal to minus 1. So minus 1 is equal to t equal to 1. So c1 and plus c2. But c1 is already 1. Okay, so 1 plus c2, and that tells you that c2 actually, 1 on the other side, should be minus 2. C2 should be minus 2. So what is the correct answer here? Y is equal to C1. C1 is 1 t and C2 is minus 2. If I'm not, okay, yeah, minus 2t square. T minus 2t square. Okay, t minus 2t square, correct? right? Okay, t minus 2t square. Farhan says that for previous question, domain is given. If domain is given for previous question, answers will change. Then we can have global maxima, global minima. Okay. So let's wait for the actual question. I've told you the concept of the previous question. So t minus 2t square. Okay, y is equal to t minus 2t square. And the question was, just a second, what was the final question? What is the maximum value of yt over the interval 0, 1? Now, here some domain is given. Here some domain is given. See, what is y dash now? 1 minus 2t equal to 0. So t equal to 1 by 2 is the stationary point. Okay. Now, no need to confirm whether that is local maxima, local minima. What I can only do? I can check the value of the function at 0. What is y0? Is 0. Okay. What is y? 1 by 2, the stationary point. So 1 by 2 minus twice of 1 by 2 square, that is 1 by 4. Okay, so this is also 1 by 2 minus 1 by 2, 0. And what is the value of y1? Is 1 minus 2, which is minus 1. They are asking maximum value over the 0, 1. The maximum value has to be 0. The maximum value over the interval 0, 1 is equal to the 0. That is what is the condition actually coming up. Okay, that is what is the condition coming up. Because if you take the second derivative, minus 2, that is a point of local maxima. Okay, so this is how. Okay, function at origin is also 0. Function at origin is also 0. T equal to half will be local maxima. But at half, again the value is 0. And because it is local maxima, okay, because it is local maxima at t equal to half, 1 second, 1 by 2 minus twice of 1 by 2 square, which is correct. Function is increasing up to this point. At half, 1 by 2 minus 1 by 2. Minus twice of 1 by 4, which is 1 by 2, which is again 0. Okay, and then it goes to minus 1. Okay, this is 1. The value here is minus 1. The value here at 0. The value here is 0. That is for sure. Okay, so maximum value is then 0. Maximum value is 0 only, correct? The maximum value is 0. Okay, dear. Next question. Okay, let me see what is the next question I have. Okay, confirm me if this is what is the interval given. Just have to confirm me if this is what is the interval given. Okay, because if I take the second derivative, that is representing maxima, local maxima only. There is no pi part also, that is also correct. C1 plus C2 square, y dash 0 equal to y dash 0. I have calculated 2 C2t. Okay, so this is equal to y dash 0 1. 1 is equal to C1, correct, and y dash 1. Okay. This is the value correction. That is what. Okay, a small calculation correction I will do here. Just wait for a moment. Okay, so minus 1 is equal to C1 plus 2C2 actually. C1 plus 2C2. So minus 1 equal to, yeah, that is what. Otherwise, the value was not coming as consistent. So C2 actually is minus 1. C2 actually is turning out to be minus 2 by 2, minus 1. Okay, C2 is turning out to be minus 1. Okay, so the actual function, dear, just a minute. The actual function. So what is my actual function? T minus t square, and y dash will become 1 minus 2t. Okay, y dash will become 1 minus 2t. C2 is minus 1. Okay, y dash will become correct. Yeah, now it is correct. Okay, and y double dash will be minus 2. Okay, now if you take t equal to 1 by 2 as the stationary point, and let me repeat the values. Y0 is 0. Y1 is again 0. Okay, but y1 by 2. Y1 by 2. 1 by 2 minus 1 by 4, and that is 1 by 4. So the maximum value is 1 by 4. It is going to be something like this. It is going to be something of this kind. Okay, so 1 by 4. This is the maximum value. Correct. The maximum value is 1 by 4. Right, dear? Yes, dear. Yeah, so there is a small calculation correction. So 1 by 2. The maximum value is 1 by 4, 0.25. NAT question it is, na? 0.25, and this is what is the maxima of the function. This is what is the maxima of the function. Correct? This graph is not required then. Okay, dear. Next question. Okay. So yeah, let me bring up the next question. What is the next question then? Okay. It's a 2 marks MSQ question for ECE, as always expected from complex contour integrals. Okay, so the question is, contour integrals evaluated counterclockwise on the unit circle C in the complex plane, identify correct statements. Okay, identify correct statements. Integral sec z dz. Okay, you don't have to evaluate. They're just asking which of them will be 0 or non-zero. Integral sec z dz not equal to 0. Okay, integral of z power n dz equal to 0 over the contour C, where n is an even integer. Okay, n is equal to even integer. Option number C, integral cos z dz not equal to 0. Option number D, integral e power z dz equal to 0. Okay, now have a look into it, dear. Have a look into it. First of all, let's look into the easy options. Okay, integral e power z. Okay, e power z is, a complete analytic function, exponential. It is analytic everywhere, not only on the unit circle. An integral of analytic function over any closed curve is always 0, so D correct. Okay, similarly, z power n being a even integer, n being a even positive integer, that is what I think is mentioned, n being a even positive integer, that means what is the type of function now given to you is, okay, again a polynomial z square, z power 4, anything, even if you have odd positive integer, doesn't matter. Okay, so again, integration for analytic function over any closed curve is equal to 0. Okay, so this also will be correct. Okay, now sec z and cos z. See, cos z is also analytic. So integral cos z should also be 0. So this is wrong. This should also be 0. Now sec z will definitely have singularities. Where? Sec z will definitely have the singularities. Where? That is at 1 upon cos z. Okay, 1 upon cos z if I write down, and sec z will tend to infinity when cos z equal to 0, and the cos z is equal to 0 where? Okay, the cos z is equal to 0 where? Tell me. Okay, the cos z is equal to 0 where? Okay, at pi by 2 plus minus pi by 2, that is the first point, plus minus then 3 pi by 2, etc. But if you take the mod z for all of them, okay, for all of them, the mod z greater than 1, because we know na cos z equal to 0 minimum at pi by 2 or minus pi by 2, but mod z, what is the pi by 2? 1.57. Okay, so mod z greater than 1, and we are evaluating over unit circle. Now, sec z is not always analytic, it is not an entire function. Okay, but if it is analytic, at least if it is analytic for each and every point, okay, within the given curve, then the answer, okay, has to be 0. So this also will be wrong. It is not equal to 0, wrong. Okay, not equal to 0, wrong. Okay, that also has to be 0. Correct, dear? That also has to be 0. Fine. Okay, so the correct option to this is B and D. Let me know, dear, what have you done? Okay, fine. Hello, hello, hello. Yeah, fine. Video is running fine only. Correct. Next question, dear. Okay. So next I have two questions from Signals. Where they have gone. Just a second. Sorry, what break? Yeah, you have? Okay. Yeah, guys. So I have some Signals and more maths question. But before that, Shankar sir is ready with control system question. So let's go with control systems. Okay. Yeah. Fine, sir. Sir, I have not seen control system till now, but students are telling that it is tricky. Is it correct this year relatively?
No, not so tricky. It's a very easy question. So like
Easy only?
Yeah.
Okay.
It's easy only. Directly, if everyone is followed the basic concept,
Okay.
it is very clear thing. So there is a 2 marks question, 2 marks MCQ. This is very conceptual question. Basic concept from root locus and controllers topic is mixing. So here there is a block diagram. Input is R of S, and there is a controller block. Controller block is given as M of S, and there is a plant transfer function that is given as G of S. G of S is separately given. Let me write down in this block itself. 1 by 10 S square, and the output is C of S. So here now based on this, there are some two statements are given. Out of the two statements, we need to identify which one is correct and which one is wrong, or both are correct or one is correct or not. So what is the statement? The first statement is there exists no controller of the form there exists there exists no controller of the form M of S is equal to Ki divided by S, of course, where Ki is a positive real number such that closed loop system is a stable. Closed loop system is stable. Similarly, another statement is given. There exists at least one controller M of S is equal to Kp plus S multiplied with Kd, where this normal notation is same. Kp and Kd are controller constants such that closed loop system is stable here also. So out of these two statements, we should identify which one is correct, which one is false, or both are correct or both are wrong. Now if you see the plant transfer function, this plant transfer function is basically type 2 plant. So type 2 plant, that means, say for example, just for time being, consider the controller is a unity gain. Let us say this block is 1. In that case, the root locus diagram, in other words, there are two poles at the origin, type 2 plant. So in this case, the roots of characteristic equation will be at the edge of, on the if you see this root locus diagram, or closed loop poles will be located on j omega axis. So the closed loop system is at the marginally stable. So for these type of systems, if you introduce an integral controller action, that means integral controller is simply nothing but introducing a pole to the system. When you introduce the pole to the system, the effect will be the root locus diagram will be pulled into the right hand side of the S plane. So already the poles are on the j omega axis, that means patient is on the ventilator. So if you pull or if you introduce an integrator to the system, is simply nothing but removing oxygen mask to that patient, so that patient will die. Therefore there exists no controller. So for these type of systems, we should not include integral controller action. Therefore we can say that for the closed loop system to be stable, there is no controller of integral action. So that statement is true. So these type of systems, you can also say that undamped system means there is no damping in the system. In order to introduce a damping, you have to use PD control action. So with this, what we can say, both the systems are so both the statements are true. Both statements are true. So the basic concept here is we should not use integral controller for this, so that system to be stable, closed loop system to be stable, and we should use PD control action. That is a second statement. Anyhow, that is also statement is a true statement. So for this question, I can select both the options are true. Now there is another question. Sir, can I continue here or new slide? Okay. There is a one question on SFG. One block diagram is given, and this is again 2 marks MSQ. So MSQ questions are given more. So here the block diagram is this is a G1 block. That is a G2 block and there is a feedback here. So this is a given block diagram. So from this block diagram, we need to identify what is the equivalent signal flow graph. Okay. So the first SFG is just a minute. I noted down on the paper properly. So this is a G1, 1, this is a 1, this is a C of S, and here R of S, this is also 1, this is G of 2, so this is a minus 1. So this is a 1 SFG given here, and second SFG is signal flow graph, I mean. This is G of 2 and G of 1. This is minus 1. And here this is R of S and a C of S. And option C, G1, this is 1, this is 1, minus 1, this is a R of S, this is a C of S. And fourth option is, it is almost similar to option B. Now, by looking into these 4 SFGs, we can say that this one, the forward path, this is a G1 with a gain of 1 and 1. This summing junction can be divided into 2 parts. And there is another forward path with a G2 and the feedback path is minus 1. So, if you see in these 2 cases, we can consider these 2 options will be correct answers. Option A and option C will be correct answers. Even if you verify this, in the numerator there are 2 forward paths, G1 plus G2. Denominator 1 minus of minus plus G1. Okay, so that will be the closed loop transfer function. Even from the block diagram as well as SFGs, option A and C both will give you the same answers. So this is another question. Next, there is a 1 mark MCQ. There is a 1 mark MCQ. Here, there is a one block diagram given. In this block diagram, this block is K, and this is a transfer function G, C of S, and the input is R of S, and in the feedback it is given that unity feedback system. So this is a system. Now what is the question here? For what value of K will the system have closed loop pole at -1 plus G1? So for this given system, root locus diagram is also given. So the root locus diagram is this is the root locus diagram, right? Now this point is this point is 0. This is a basically a graph plus J1 plus J1 minus J1, and here this is a -1, and here this is a -2, this is -3, and this point is at a -4. So this is what the x-axis, and the root locus diagram given also. For what value of K will the system, let me write down the question statement here. For what value of K will the system have for what value of K will the system have closed loop pole at S is equal to -1 plus J1. S is equal to -1 plus J1. So the options are: for no positive values of K, the second option is for all positive values of K, and K is equal to 5. Option D is K is equal to 1 by 5. Now it's a very clear indication, we don't need any calculations also. The root locus diagram is not passing through the given test point. So that is a -1 plus J1. So root locus diagram is not passing through the given test point. Okay. So root locus diagram, basically the definition is, root locus diagram is nothing but it is a solution of roots of characteristic equation for different values of K, that is varying from 0 to infinity. But any value of k, the plot is not passing through -1 plus j1. Therefore, what we can say that we can select option A will be the correct answer for no values of k. So these are all the questions I have from control systems. We'll collect a few more. I think there are more couple of questions are there in the control systems. We'll discuss that next one. You know, so next subject will be carried by another my colleague faculties. I hope, can anyone please respond how is the difficulty level of the paper? Yeah, this is true. Here you will also have plus G2 in the denominator. That is correct, Shashikiran Patel. Next, Gautam sir will continue. Magnet. అది అందుకే నేను లాగ్ కనబడుతుంది.
Hi guys, a very good evening. Let me quickly go through all the questions in today's ECE paper from the subjects of analog, EDC and networks. And at the outset, let me tell you that all questions are extremely easy. Okay, I mean, just now I had a discussion with our MY sir who teaches communication. Communications, some really good questions have come, and all questions involve some type of logic. But as far as EDC, networks, and analog is concerned, no need of any logic. Just look at the question, put one simple formula, you'll get the answer. Okay. So, I hope I'm audible. Let me check. వినిపిస్తుందా ఒకసారి చెక్ చేయి. All right, let's get started. So first, we have a 1 mark. Oh. MSQ question, and this is from analog circuits. So 4 statements are given. You have to identify the correct statements. Okay. So identify all the correct statements. I think all statements are regarding ideal op amp. Okay. So identify the correct statements about ideal op amp. Let me change the color. So the first statement is what? That for the ideal op amp, you have infinite output resistance, which is incorrect. Ideal op amp has zero output resistance. Okay. And the second statement is what? Ideal op amp has infinite input resistance. This is correct. Third option is what? Ideal op amp has infinite open loop common mode gain. Ideal op amp is actually what? An ideal differential amplifier. Ideal differential amplifier will have zero common mode gain, so that its CMRR also will be what? Infinite. Okay. So this is incorrect. It has zero common mode gain. And the D statement or the D option is what? It has infinite open loop differential gain. This is correct. Ideal op amp has a very large differential gain. In fact, that gain will tend to what? Infinity. So the correct statements are infinite Rin and infinite differential gain. Okay. Moving on, there is another 1 mark question, and this is a numerical type answer for the question, and this is also from analog circuits. So what is given in this question? Some band pass filter is given, an active band pass filter is given. This is the given circuit, okay? And the component values are R10C and 0.1C and then 2R. Yes, and for this band pass filter, it's already given that the lower cutoff frequency is what? 1 megahertz. And the question is to find what is the, or find the value of the higher cutoff frequency in units of megahertz, okay? I mean, one thing you can do is what? You can find the transfer function where you treat this series combination as one impedance and you treat this parallel combination as what? Another impedance. Then it is what? The simple inverting amplifier whose gain is what? Minus Z2 by Z1. In that way, you can write the transfer function. In the transfer function, in the denominator, you'll have a second degree polynomial, which means there'll be two poles, and those two poles will correspond to what? The two cutoff frequencies, okay? So the two cutoff frequencies of this particular circuit, if at all you write the transfer function, they turn out to be, if this is R1, if this is C1, okay, let me call this R1, let me call this C1. So one cutoff frequency will definitely be 1 by R1 C1. Of course, units will be radians per second, but there is what? Hertz, okay? And then if you call this as C2 and this as R2, the other cutoff frequency will be what? 1 by R2 C2. So what are the two cutoff frequencies of this band pass filter? 1 by R1 C1, 1 by R2 C2. Now, which one is higher cutoff frequency, which one is lower cutoff frequency? That actually depends on the values of R1, R2, C1 and C2. But already the lower cutoff frequency is given to be 1 megahertz. The other cutoff frequency will definitely be greater than 1 megahertz. Okay. All right. Now, 1 by R1 C1. R1 is R, C1 is what? 10C. So this will be 1 by 10 RC. The other cutoff frequency, which is 1 by R2 C2, where R2 is what? Oh, sorry. I'm sorry. This is C2 and this is R2. Okay. The other cutoff frequency will be what? Where R2 is 2R, C2 is what? 0.1C. 1 by R2 times C2 will be what? 2 times 0.1 is what? 0.2. So this will be 1 by 0.2 RC. 1 by 0.2 is what? 5. So this is what? 5 by RC. So look at the two cutoff frequencies. One cutoff frequency is what? 1 by 10 RC. 1 by 10 is what? 0.1. 0.1 by RC. The other one is what? 5 divided by RC. So clearly 5 by RC is more than this. So that means this is going to be the higher cutoff frequency. This is going to be the lower cutoff frequency, omega L. And omega L is what? 2 pi FL. Yes or no? So 2 pi FL equal to what? 1 by 10 RC. So what is FL? 1 by 2 pi into 10 RC. Now the question is what? To find FH. Already omega H is what? 5 by RC. So FH will be what? Omega H divided by 2 pi, which is 5 by 2 pi RC. Now if you go back to this equation, what is 1 by 2 pi RC? 1 by 2 pi RC will be what? FL into 10. FL is what? 1 megahertz. So 1 into 10 is what? 10. So the value of 1 by 2 pi RC is what? 10 megahertz. Now you come back to this FH thing, which is 5 times 1 by 2 pi RC. So in place of 1 by 2 pi RC, I can just write 10. 5 times 10 is what? 50, and units are what? 50 megahertz. So what is the answer to this question? It is exactly 50. Okay. Moving on to the next question, which is another 1 mark question, and this is MCQ. This is also from analog circuits. The small signal equivalent circuit of some amplifier is given, okay, where the small signal input voltage is what? Vs, and there is some resistance Rs, and then in place of the transistor, we have this RPi model, where this is what? The small signal base current, and this is what? Beta IB, and the emitter is connected to ground. So this is what? A simple common emitter amplifier, where the input is applied at the base or on the base side, and output is taken at the collector. Okay, this is the given circuit, which is the small signal equivalent circuit of some amplifier. Okay, V0 is what? The small signal output, Vs is what? The small signal input, and the question is what? Find V0 by Vs. That is what? The small signal voltage gain. Okay, I mean, this is pretty simple. There's nothing in this. Okay, so this beta IB will flow through RL like this. So V0 can be written as what? Minus beta IB into RL. And this IB is nothing but the current in this branch, which is Vs upon Rs plus R pi. Now you come back to this. In place of IB, I can write, okay, first we have minus beta. Then in place of IB, I'll just write Vs upon Rs plus R pi times RL. That's all. So what is V0 by Vs, or the small signal voltage gain? It is minus beta RL upon Rs plus R pi. Okay. Let's move on to the next question. This is a 2 mark question. This is also an MCQ, and this is also from analog circuits. Okay. I mean, some current mirror kind of circuit is given, which is made using BJTs. Alright, this is the given circuit. So in this circuit, there are two PNP transistors. Okay, if you want, you can call this Q1. You can call the other transistors what Q2. Along with the two transistors, there's also this Zener diode. Yes, and this is the load resistance through which the current is what IL. A bunch of values are given. For each transistor, the value of VEB is what 0.7 volts, and for each transistor, the current gain is what 120. And for the Zener diode, the breakdown voltage is what 5 volts, and the reverse current through the Zener diode, that is IZ, is what 25 milliamps. Even the load current is given, which is 12 milliamps. Okay, and the question is to find the values of R1 and R2 in units of kilo ohms. So what is R1 in kilo ohms and also what is R2 in kilo ohms? That is the question. It's pretty simple. See, what is this drop? It is 0.7. Now because the value of IZ is positive, it is understood that the Zener diode will operate in reverse breakdown, and also the Zener diode in breakdown will behave like a battery of value Vz. So across the Zener diode, you just write down the drop, a voltage drop of Vz, which is 5 volts, and also show this current as what is it 25? Yeah, and this current is what 25 milliamps. Now if you start from this node where the voltage is what 20, then you go from plus to minus, again you go from plus to minus. So what is the voltage at this point? 20 minus 0.7 minus 5. 20 minus 5.7, which is 14.3 volts. Okay, that is the voltage at this node. And also the value of IL is given. IL is what 12 milliamps. I think in the question it is also given that both are operating in active. I mean, if you look at Q1 base is shorted to collector, it is guaranteed to operate in active. Q2 also, R1, RL are such that Q2 also operates in active. Okay. So this 12 milliamps, is it not the collector current of Q2? And if you know the collector current, and because it is already given that Q2 is inactive, can't you find the base current? So this, I'll call it IB. So what will IB be? It will be IC divided by beta. 12 milliamps. Beta is what? 120. 12 by 120 is what? 1 by 10, which is 0.1 milliamps. Okay. Now if you look at this node, from the top 25 milliamps is entering, and from this side 0.1 milliamps is entering. So what is the current that will flow through R1? It is 25.1 milliamps. That's all. And then what is the drop across R1? It is 14.3 volts. So drop divided by current will give you what? The value of R1. And the other thing is what? What is this voltage drop? Again VEB, which is 0.7. This is 14.3. Go from minus to plus. Just add the drop. 14.3 plus 0.7 is what? 15 volts. So what is the drop across R2? It is 5 volts. And this current or this branch current is nothing but the emitter current of Q2. So this is nothing but IE. I mean, you can find IE because we already know the value of IB. IB plus IC. IC is 12, IB is what? 0.1. So this emitter current is what? 12.1 milliamps. So what is R1? Ohm's law. 14.3 by 25.1. 14.3 by 25.1 milliamps. And R2 will be what? 5 volts divided by 12.1 milliamps. Okay. Let me take out my calculator and get the values. .3 divided by 25.1. So this R1 is what 0.6, I mean 0.57 or 0.6 kilo ohms, and R2 is what 5 divided by 12.1, 0.4 kilo ohms. These are the values of R1 and R2. All right, let's move on to the next question. Next up, we have a 1 mark question, and this is an MCQ. This again is from analog circuits. Just draw the circuit diagram first. So this is the transistor whose current gain is what 100. Even the base current is given, it is 10 microamps. The question is what to find the value of VCE in volts. So what is that VCE? VCE is nothing but the drop between collector and emitter. Okay. And what is this current? It is the base current. I mean, because of this resistance RB connected between base and collector, the transistor will definitely operate in active. Okay. And this current is given as 10 microamps. So transistor in active. So IC is equal to what? Like beta IB. 10 microamps into 100, it is what? 1 milliamp. Okay. So this is what the collector current. So this current, if you write KCL at this node, it turns out to be equal to what? IC plus IB. So in terms of value, this current is same as what? IE. Okay. And IE is what? 1.01 milliamps. Okay. IC plus IB. 10 microamps is what? 0.01 milliamps. Okay. This current, of course, is what? IE. So can't you find this drop? What will this drop be? 5 kilo ohms into this will be what? 5.05 volts. You can also find this drop. IE into 3K. IE is what? 1. So is what? 3 volts. So what will VCE be? 10 minus this drop minus this drop. So 10 minus 5.05 plus 3. I hope I am correct. This is so 8, I think 1.95. Let me just, yeah, it is 1.95. And this is a pretty simple question. Moving on to another question from analog circuits. This is a 2 mark question, and this is an MSQ. This is also from analog circuits. So in this question, a bridge rectifier circuit is given. Okay, let me draw that bridge rectifier circuit. The input is what? Vi, and the current drawn from the input source is called as I1. Okay, and V0 is what? The voltage across RL. Okay, actually among the options, 4 plots are given. 2 of the plots are the plot between I1 and Vi. Okay, plot I1 versus Vi, and also you should plot V0 versus Vi. And while plotting these two things, I1 versus Vi and V0 versus Vi, it is given that Vi is varied from minus M to plus M. M is some positive value, okay? So minus M to plus M, that is the range over which Vi is varied, okay? So when you vary Vi over that range from minus M up to plus M, how does I1 vary with respect to Vi? And also how does V0 vary with respect to Vi? Okay, you have to identify the correct plot for this one and also for this one. So basically you have to select two plots, okay? That is why it is MSQ, okay? I mean, when Vi is positive, if Vi is positive, how will current flow in the circuit? Current will flow like this. Yes or no? And of course, it is given that all the diodes are ideal. So these two diodes, when they turn on, they'll become short circuits. Then RL will be directly connected across what Vi, and Vi. Sorry. So when Vi is positive, V not equal to what Vi. And what about I1? Even I1 will be what? Vi divided by RL. Vi divided by RL. Okay. This is for positive values of input. Now the same input can also be negative. Okay. So if input is negative, this will be higher potential, this will be lower potential. This time the current, okay, I mean I made a small mistake while drawing the circuit. Please pardon me for that. I'm sorry guys, this is the actual given circuit, okay. So during the earlier positive half cycle where the input is what? Positive, the current is going to flow like this, okay. And V0 is what? Vi, and I1 is what? Vi divided by RL, that is fine. Now we are looking at the case where input is negative. As I already said, this will be higher potential compared to this. This time the current will flow around the circuit like this. So this is how the current will flow. Now this diode and this diode will be on. Again, they'll become short circuits. So the point to note is what? Whether input is positive or negative, current through RL will always flow in the same direction. That is from plus to minus. So here also V0. So this time V0 will be equal to minus Vi. So this time V0 will be equal to what? Minus Vi, because this plus will be shorted with minus, minus will be shorted with plus. I mean, there is a basic point. So V0 equal to what? Minus Vi. And the current will flow in the opposite direction of I1. Yes or no? I1 direction is what? Like this. But during negative half cycle, when input is negative, current will flow in the opposite direction of I1. So I1 will definitely be negative. So I1 will be what? Minus Vi by RL. Okay. That's all. No, I think this will be plus Vi by RL. Okay. I mean, I1 will be negative, right? And Vi is already negative. So I1 will be Vi by RL. Vi goes from negative value to positive value. I1 will be equal to Vi by RL. I mean, I1 is negative, Vi is also negative. So I1 and Vi must have same sign. Yeah. So I'll just draw the plot. So one is V0 versus Vi plot. The other one is what? I1 versus VI plot. Okay. V0 versus VI plot will be having a V shape. When input is positive, output is also positive. When input is negative, output is positive. Okay, like V0 equal to what? Minus Vi. This is Y equal to X, this is Y equal to minus X. Okay. And then I1, whether input is positive or negative, it is always equal to what? Vi by RL. This is the plot between I1 and Vi. Okay. That's all. Among the options, you have to pick this and this. Okay, because it's an MSQ, there are two correct options. Okay. There is another 2-mark question, and this is numerical answer type, and this is also from analog circuits. Okay. So here, a simple diode circuit is given. This is a 5-volt source, and it is given that diode is ideal. If diode is ideal, its on voltage will be what? 0. Okay. And the applied input is 10 sine 100 pi t volts. The question is this: the duration for which diode is on during one cycle is dash milliseconds. That means in one cycle, what is the amount of time for which the diode will be on? I mean, it's a single diode circuit, so for the diode to be on, the voltage across the diode or the open circuit voltage across the diode should exceed V on. And V on is what? 0, because diode is what? Ideal. So just assume diode has been removed, and then you try to find VOC. So when you remove the diode to find its VOC, current in the circuit will become 0. There will be no drop across R. Yes, then VOC will be what? Vi minus 5. Okay. So VOC is what? Vi minus 5, which is Vi plus 5. Yes or no? Vi minus 5, which is Vi plus 5. And this VOC, it should be greater than V on. Ideal diode V on is what? 0. So Vi should be greater than minus 5. Now in place of Vi, you write the given input. So this 100 pi t thing, at this moment, I'll simply call it theta. Okay. So 10 sine theta greater than minus 5. That means sine theta greater than minus 0.5, or you can call minus half. Okay. So sine theta has to be greater than minus 0.5. So first of all, what are the values of theta where sine theta will be minus 0.5? Okay. This is sine theta over one cycle. So here you will have minus 0.5. Okay. So this we'll call it theta 1, and this we'll call it theta 2. So between theta 1 and theta 2, sine theta will be less than minus 0.5. By the way, this is minus 0.5. Okay. So during this portion, the diode will be off. For the rest of the cycle, the diode will be on. Okay. And this theta 1 will be what? 180 plus 30. Sine 180 plus 30 is what? Sine 210, which is minus 0.5. So this is 210 degrees. Theta 2 will be what? 360 minus 30, which is 330 degrees. Okay. So what is the angle over which the diode will not conduct, or the diode will be off? 330 degrees minus 210 degrees, which is 120 degrees. Yes, so that is the angle over which the diode will be off. What is the complete angle in one cycle? 360. And out of 360 for 120 degrees, the diode is off. For the remaining 240, that means what? 2/3 of the cycle, diode will be on. Okay, 1/3 of the cycle, diode will be off. That is the thing. Okay. So T on, the duration for which the diode will be on. Just now I told you what? 2/3 of the cycle, diode will be on. One cycle duration is what? Capital T. So 2/3 into capital T. Now you go back to the given input, sine 10 sine 100 pi t. What is this 100 pi? Omega. So once you know omega, can't you find capital T, which is 2 pi by omega? So 2/3 into 2 pi by omega, where omega is what? 100 pi. 2/3 into 2 pi by 100 pi. If you just calculate the value of this, your answer will come out in seconds. But the question is what? To find the answer in milliseconds. Just multiply it with 1000. Okay. Now you'll get the final answer. Let's see what it is. 2 into 2 into 3.14. Okay, pi will get cancelled, right? Sorry. Pi and pi will get cancelled. It's actually 40/3. 40/3 is what? 13.33. Correct? Yeah. That is the answer, right? 13.33. The answer to this NAT type question is what? 13.33. Shall I continue? Okay. I think that's about it as far as analog circuits questions were concerned. So altogether we had 6 questions from analog circuits, out of which 1, 2, 3, 4. So from analog circuits we had 4 1-mark questions and 2 2-mark questions. I'm sorry. So the total weightage is more than the usual weightage, which is, today it is 10 marks. Usually it is about 7 or 8 marks. Okay. But all questions, as you can see, are very, very easy. Okay. Now let's look at the questions from EDC. Okay. So the first question is a 1-mark question and it is MSQ. As I said, now we are going to look at the EDC questions. Again, 4 options are given. Each option is what? A statement. And then among the options, you have to identify all the correct statements. Okay, MSQ. Okay. So I'll just quickly write the 4 options. CS amplifier, that is common source amplifier, has infinite input resistance. Okay. Common source amplifier has infinite input resistance, which is correct. Yes or no? Common source amplifier input is applied at the gate. At the gate, no current is drawn. So Rin is what? Infinite. Okay. B option is what? Common gate amplifier has again infinite input resistance. This is incorrect because a common gate amplifier, the input is applied at the gate, and when you look into gate, generally you see a resistance of 1/Gm. So common gate amplifier will have an input resistance which is roughly equal to what? 1/Gm. Okay, not always 1/Gm, but roughly it is equal to what? 1 by GM. Okay, but here it is given infinite input resistance, which is incorrect. The option is what? V in and V naught, that is the input voltage and output voltage of CD amplifier is what? Common drain amplifier are in phase. Common drain amplifier is also called source follower, which can be used as what? A voltage buffer, and it has a voltage gain which is very close to 1, and the voltage gain is what? Positive. Only for common source the voltage gain is what? Negative. Voltage gain positive, it means what? Output and input will be in phase. So this again is what? A correct statement. And the last option is what? Vn and V0 of CS amplifier, common source amplifier, they are saying they'll be in phase. This is incorrect. Common source amplifier gain is negative, output and input will have opposite sign, they'll be 180 degrees out of phase. So options A and C are correct. Moving on, next we have a 2-mark question, and this is an MCQ. Some MOSFET amplifier circuit is given, 5 volts, that is the supply voltage, and at the drain of each transistor, resistance of 1K is connected. And in the question, it is also given that both the transistors are identical. Okay, let this be M1, let this be M2. It is given that both are identical, and at the bottom we have a DC biasing current source whose value is what? 2 milliamps. Okay, V1 is what? The total voltage applied at the gate of M1, and V2 is what? The total voltage applied at the gate of M2, and V3 is the total voltage at the drain of M1. Okay, I already told you that both the transistors are identical, and for each transistor they are telling that the transconductance GM is what? 5 millisiemens. Okay, and V1 is this much, 2.5 volts plus 0.01 sine omega t, and V2 is what? 2.5 minus 0.01 sine omega t. Okay, this is also volts, this is also volts. Now given this, you have to find what is V3. So transconductance GM is already given, and also if you look at the given values of V1 and V2, which are the voltages at the gates of the two transistors, this 2.5 volt and this 2.5 volt, is it not DC? So, and then the remaining part is what? The AC. Or you can think of the remaining part of the V1 as what? The small signal input. Okay. So if I call 0.01 sine omega t as what? Vd, then this is also what? Vd. Now what is V1? You can say it is 2.5 plus Vd. What is V2? You can say it is 2.5 minus Vd. So at the gate of each transistor, we are applying some DC voltage and also some small signal input voltage. In that case, first we should always do what? DC analysis. So during DC analysis, so right now, I'm just doing DC analysis. The AC part will become 0, which means both the transistors, the gate will be at 2.5 volts. So this current will get equally divided between the two transistors. So this will be 1, this will also be 1. So this is 1 milliamp. This is also what? 1 milliamp. 1 milliamp through 1K will result in a drop of 1 volt. 5 minus 1 is what? 4. So the DC value of V3 is what? 4 volts. Okay. The DC value of V3 is what? 4 volts. Now we should find what is the AC voltage at this node. Or what is the AC component of V3? And for that, we should do what? AC analysis. Okay. So first, let me clear the DC values. Okay, during AC analysis, this current source will become open, this will become 0, or shorted to ground and so on. During AC analysis, right now I'm doing what? AC analysis. V1 is what? 2.5 plus VD. Forget about DC part because we are doing AC analysis. So what is the AC voltage at this gate? VD. What is the AC voltage at this gate? It is minus VD. Is the circuit symmetric? Yes. I mean, in the small signal domain, is the circuit linear or not? It is linear. Transistor by itself is what? Non-linear. But in the small signal domain, transistor can be counted as what? A linear element. Okay. So circuit is what? Linear. And it is also what? Symmetric. 1K, 1K, the two transistors are also what? Identical. So we have a symmetric circuit which is linear, but look at the two inputs driving the circuit. They are VD and minus VD. Inputs are not symmetric. You should call these two inputs are what? Anti-symmetric inputs. So we have a linear symmetric circuit driven by anti-symmetric inputs. What happens in this case is, this is what? The line of symmetry. So because of the fact that it is linear, I mean the circuit is what? Linear and symmetric, and it is being driven by anti-symmetric inputs, any point on the line of symmetry will be at zero potential. This is purely due to what? Linearity and symmetry. Okay, any point on the line of symmetry will be at zero potential. So if you're not comfortable with this approach, you can always draw the small signal equivalent circuit. Even if you do that small signal analysis, you will end up finding the voltage at this node, which is called the tail node, to be what? Zero. But without going through all that analysis, directly we can say because of symmetry and the inputs being anti-symmetric, this point will be at 0 volts. So in other words, this becomes some type of virtual ground. So this point is actually not physically connected to ground. In spite of that, this will be at 0 potential. Okay. So once you know that this is at 0 potential, forget about the current source. Current source will anyway go away. Okay. So this point can be grounded. Now this becomes a simple common source amplifier. The other half on the right side also becomes what? A simple common source amplifier. Now for a simple common source amplifier, what is the voltage gain? Minus GM times the resistance at the drain. Yes or no? So what is the gain? Minus GM times RD. Okay, GM is what? 5 millisiemens. RD is what? 1 kilo ohm. Minus 5 millisiemens into 1 kilo ohm. The gain is what? Minus 5. So what is the gain from this point to this point? It is minus 5. Yes. So this VD, when it reaches drain, it gets multiplied with minus 5. So 4 volts minus 5 VD. So V3 equal to what? 4 minus 5 VD. VD is what? 0.01. 5 times 0.01 is what? 0.05 sine omega t. In fact, if you look at the options, you don't have to do any kind of analysis. Just by looking at the options, you can pick this option. I think among the options, only 2 options have got this 4 volt DC part for V3. So the other 2 can be directly eliminated. Okay. And then when it comes to AC part, see from this point to this point, it is what? A common source amplifier. From this gate to this drain, you are going through what? The transistor. You go from gate to drain, you are going through what? A common source amplifier whose voltage gain will be what? Negative. Even we found the gain to be what? Minus 5, which is negative. So there will always be a sign change. Okay, here VD is what? Plus 0.01 sine something. When it becomes negative, it will become minus something times the same sine omega t. So just by using the simple logic, you can straight away pick the correct option without doing all this analysis. Okay. Anyway, I'll just, so there is the answer. Okay. 4 minus 0.05 sine omega t, that is the answer. So I'll just move on to the next question. I'll finish off ADC, then I'll hand it over. So next up, we have a 1 mark question, which is an MSQ. I mean, there's not even a question. Which of the Which of the following impurities can be called as N-type dopant? Dopant means what? The impurity, okay? So 4 different atoms are given. One is gallium. Gallium belongs to what? Group 3. Group 3 is what? Acceptor, it makes it P-type, okay? B option is phosphorus, group 5. It is a donor, it makes it N-type. C option is boron, again group 3, incorrect. D option is arsenic. Arsenic also belongs to group 5, just like phosphorus. So options B and D are correct, okay? Next we have a 2-mark question, and this is an MCQ, and this is also from EDC. Alright, what is given in this question? There is an intrinsic semiconductor, okay? Or there is a semiconductor whose value of Ni is what? 2.5 into 10 to the 16 per centimeter cube. Sorry. Ni is what? 2.5 into 10 to the 16 per cm cube. And the mobility values of the two carriers are given. Mu n is what? 0.15 meter square per volt second. And mu p is what? 0.05 meter square per volt second. Sir, just check if the audio is working or not. Audio. It's coming, no? Okay, fine. So those are the values of mu n and mu p. Okay. You have to find the intrinsic resistivity. In units of kilo ohm meters. You have to find intrinsic resistivity. I mean, what is there in this? Rho I. Rho is what? Resistivity. I for intrinsic. Intrinsic resistivity is what? Inverse of intrinsic conductivity. And intrinsic conductivity is what? Q Ni times mu n plus mu p. Okay. Q is what? 1.6 into 10 to the minus 19. Ni is what? 2.5 into 10 to the 16. I think this is not per centimeter cube, it is actually per meter cube. Okay, let me correct it. .5 into 10 to the 16 per meter cube, and then mu n plus mu p. What is mu n plus mu p? 0.15 plus 0.05, which is 0.2. That's all. Let's find the value of this. Okay, and also it should be in kilo ohm meters, right? See, 1 by 0.2 is what? 5. 5 by 2.5 is what? 2. 2 divided by 1.6. This is the value I am getting. 1.25 into 10 to the 3 ohm meter. And 10 power 3 ohm meter is nothing but kilo ohm meter. So what is the answer? It is 1.25. Okay, it's an MCQ. So the correct option is what? 1.25. Next, we have another 2-mark question, and this is also an MCQ. This again is from EDC. So in this question, it is given that an electric field of let me write it. An electric field of 0.01 volts per meter is applied across, not across, along, okay? It is applied along the length of a copper wire. An electric field of 0.01 volts per meter is applied along the length of a copper wire of circular cross section. So copper wire, just like any other wire, has got a circular cross section with a diameter of 1 mm. So the diameter of that copper wire is what, 1 mm, and then it is given that conductivity of copper. Conductivity is what, a material property. Conductivity of copper is what, 5.8 into 10 power 7 Siemens per meter. Siemens per meter. And the question is to find the value of the current. Current flowing through the wire is how much? Current flowing through the wire is dash amperes. So you have to find the current in units of amperes. So what is given? Electric field is given. The diameter is also given. Conductivity sigma is also given. Okay. I mean, J is equal to what? Sigma times E, and I is what? The area of cross section times the current density. This J is what? The drift current density. Okay. So is it not A sigma E? Yes. And A is what? Pi d square by 4 times sigma times E. Just have to plug the values into this expression and get the final answer. Okay, pi into d is what? 1 mm. Okay. I mean, if you look at the units for the other quantities, electric field is what? In units of volts per meter, and even conductivity is what? In units of what is it? Siemens per meter. So this diameter should also be expressed in units of meters. So 1 mm is what? 10 power minus 3 meters. So pi d square, pi into 10 power minus 6 by 4 into sigma. Sigma is what? 5.8 into 10 to the 7. And then you have electric field. Electric field is what? 0.01. You just have to find the value. Okay. I'm getting this value for the current, 0.46 amperes. That is the value of I, or that is the current that will flow through this copper wire. I mean, there's nothing in this. Okay. J equal to sigma E, you know it is what? The point form of Ohm's law, and then multiply J with A. You'll get the actual current. Okay. There is another very silly question. I think this is the most unexpected question in today's ECE paper. Okay, nobody would have expected a question like this, and that too for 2 marks. I think this is the biggest joke as far as today's exam is concerned. Okay, so let me tell you what that joke is. So it's a 2-mark joke. and also it is an MCQ. So in germanium, it is given that in germanium, the mobility value is given 0.38 meter square per volt second. And this is at room temperature, which is 300 Kelvin. Now in the same material, that is germanium, you have been asked to find the diffusion coefficient. Given is what? Mobility, which is related to what? Drift current at the moment of carrier in presence of electric field. What is the value of dn? And you should find dn in units of centimeter square per volt second. Okay, and this is also at 300 K. I mean, it is just the application of Einstein's relation. Yes or no? Which is dn equal to what? Vt times mu n. Vt, thermal voltage at room temperature is what? 0.026 volts. And then mobility is what? 0.38. Because see, we need to find dn in centimeter square per volt second. Convert this meter square into centimeter square. Meter square, 1 meter is what? 100 centimeters. So meter square is what? 10 power 4 centimeter square. So this is actually same as what? 0.38 into 10 to the 4, which is 3800 centimeter square per volt second. 3800 centimeter square per volt second. That's all right. So this volt go away. They get cancelled out. So 3800 into 0.026. That is our answer. 3800 into 0.026. 98.8. I hope this is correct. 98.8 centimeter square per volt second. That's all. These are the different questions we got from EDC. Okay, so as you can see, all are very, very easy questions. So in the same flow, let me also complete discussing network theory questions. So from op-amp, discussed. So let me quickly discuss the questions from networks. Okay, so from networks, we have about 4 questions. Okay, 2 2-mark questions and 2 1-mark questions. So first we look at a 1-mark question, and this is an MCQ. So some network is given. This is 9 volts. This is 3 ohms. And on this side some network is connected. And here we have 8 volts. This is 2 ohms. This is 1 ohm. And it is given that the current through this 3 ohm resistor is what? 1 ampere in the downward direction. And the voltage at this node is what? Vx. So the question is what? To find the value of Vx. I mean, there's nothing in this. So what is this? What is this drop across 3 ohms? It is 3 volts. 9 minus 3. So here it is what? 6. So whatever be this network, these two will be in series. Okay, so directly we can write Vx in terms of 8 and 6. So just cross multiply. Okay, so multiply 8 with 1, which is 8, 6 with 2, which is 12, divided by 2 plus 1, which is 3. 20 by 3 volts. So what is the answer? It is 20 by 3. Okay. There is another 1-mark question, and this is also an MCQ. This is again from networks. So again we have a network that has R, L, C connected in parallel. Okay, so you have a capacitor, then you have an inductor, and you also have a resistor, and this is driven by an AC voltage source whose phasor value of voltage is what one at an angle 90 degrees volts. Okay, and for each of these three elements, the corresponding admittance values are given. Yes, so for the capacitor, the admittance is what J 0.25 S, and for the inductor, the admittance is what minus J 0.15 S, S for Siemens. Okay, and for the resistor, the admittance or the conductance is what 0.2 Siemens. You have to find what is the phasor current through each of these three elements. Okay, so what is IC, what is IL, and then what is I, or I mean what is there? This is just Ohm's law. Okay, so current is equal to, I mean this voltage what, same for all the elements. Current is what, voltage times admittance, because admittance is already given. Okay, so what is IC, 1 at an angle 90 degrees volts, times the admittance, which is J 0.25. J is also at angle 90 degrees, right? So angle 90 into angle 90 is what? Angle 180 degrees. Okay. So 0.25 at an angle 180. Angle 180 is what? Same as minus 1. So you can say minus 0.25 amps. Okay. And then when it comes to IL, again multiply voltage with impedance. So one angle 90 degrees into minus J times 0.5. Minus J is what? Angle minus 90. Angle 90, angle minus 90 will get cancelled. So it is just 0.15 at an angle 0 degrees amps. And then IR will again be 1 at an angle 90 degrees into the admittance, which is 0.2. So this is what? 0.2 at an angle 90 degrees. I mean, this is such a simple question. These are the values of IC, IL, and IR. There are two more questions which I will quickly discuss. There is a simple question from two-port networks, and this is a 2-mark question, and this is MCQ. You need to find the Z parameters of the given two-port network. Find Z parameters of the given network. So let me draw what is the given network. So all resistances are identical. All of them have a value of 2 ohms. That's all. I mean, if you look at this network, it's a resistive network. So it obeys reciprocity. So Z12 will be equal to what? Z21. And also there is symmetry. If I draw a line here, I can split the circuit or the network into what? Two identical halves. So it is what? Symmetric. So it has symmetry as well, which means Z11 equal to what? Z22. Okay. So if this is V1, this will be I1. And if this is V2, this will be I2. So what is Z11 by definition? It is V1 by I1 when I2 is 0. I2 0, it means what? No current will flow here, or this port becomes open. You can forget about this. Now V1 by I1 is like finding the equivalent resistance of this network, okay, without this 2 ohm, okay. 2 and 2 in series is what? 4, 4 in parallel 2 is what? 4 into 2, 8 by 6, which is 4 by 3, 4 by 3 plus 2. So Z11 is what? 10 by 3 ohms, and because it is symmetric, Z22 will also be 10 by 3 ohms, okay. Now let's find Z12. What is Z12 by definition? I think it is V1 by I2 when I1 is 0, okay. Alright, now we have to make I1 0. When you make I1 0, this drop will become 0. Then this V1 will also be same as what? This drop. Then this current anyway is what? I2. Now at this point, this I2 will divide itself into two parts. One part will flow in this path, the remaining current will flow in this path. So how much current will flow in this path, which has a resistance of 4 ohms? I2 into 2 divided by 6. 2 by 6 is what? 1 by 3. So this current will be what? I2 by 3. So what is V1? The drop across 2, through which the current is what? I2 by 3. So 2 times the current, 2 times I2 by 3 is what? 2 I2 by 3. Okay. So V1 is what? 2 I2 by 3. V1 by I2 is what? 2 by 3. So Z12 is what? 2 by 3 ohms. And because of reciprocity, because the network is what? Resistive, this is also same as Z21. So finally we have the Z matrix, which is 10 by 3, 2 by 3, again 2 by 3, and then 10 by 3 ohms. This is the correct answer. Moving on to the last question from networks. So this is also a 2-mark question, and there is also an MCQ. Basically, some AC network is given, and in that AC network, we have a branch that contains R, L, and C connected in series. Resistance value is given, inductance value is also given. You should find the value of the capacitance, okay? And then it is also given that that the RMS current in this branch is what? 5 amperes, okay? And the RMS voltage across this entire branch happens to be 25 volts RMS. What is the RMS current through each and every element? 5 amps. What is the RMS voltage across this entire branch, which is a combination of R, L, and C? It is 25 volts RMS. So given this thing, and also the operating frequency is given, it seems, and that is 200 radians per second. This is the operating frequency. And the question is what? To find the value of the capacitance. So find C. And this is also very simple. So this series combination of R, L, and C will have some net impedance, let it be some Z. Okay. Now let the phasor voltage across this be some V, and let the phasor current through this be some I. Now what is this Z? Isn't it V by I? Yes or no? And then mod Z is nothing but mod V by mod I. And mod V is what? 25 volts RMS. Mod I is what? 5 amps RMS. Yes or no? 25 volts RMS by 5 amps RMS. Volts by amps is what? Ohms. So the magnitude of this equivalent impedance of this branch is what? 5 ohms. And what is Z itself? It is 5 plus what is the impedance of the inductor at this frequency of 200 radians per second? J into omega into L, which is J 200 plus 1 by J omega C, which is same as 5 plus J into 200 minus 1 by omega C. And then mod Z is what? 5. What is the magnitude of this complex number? So square root of this square plus this square equal to what? 5. Now if you square it on both the sides, won't you get 25 plus 200 minus 1 by omega C whole square equal to what? 25. 25 cancel out. That means what? The value of this has to be 0. And that is possible only when 200 equal to what? 1 by omega C. And omega is again 200. So 1 by 200 C. So what is C? I think it is 1 by 200 into 200, which is 1 by 4 into 10 to the 4. Please correct me if I am wrong. I am getting C as what? 1 by 4 into 10 power 4. So if you want to find it in units of microfarad, yes, you just multiply this with 10 power 6 and the value will come out in microfarad. 10 power 6 by 10 power 4 is what? 100. 100 by 4 is what? 25. So the value of C, or the capacitance, is what? 25 microfarad. So that's about it with regard to EDC, analog circuits, and network theory. Yes, and let me tell you that all questions from these three subjects have been extremely easy. So anyone who has seriously prepared should be able to score full marks in these three subjects. I think these three subjects put together have a weightage of around 30 marks. So 30 marks have been gifted to you, literally. And from all the other subjects, if you can manage to score another 30 marks, then you are in very good position. Okay. Anyway, who is next? Okay. Now Hemant sir will take over and he'll discuss digital and also EMT. Yeah. No question, sir. Ready? Yeah. PPT. Yeah. Just go. EDC. Okay.
PDF.
Producer has read it.
No, it's already there. It's already in the
Okay. You downloaded?
just important here.
Which one? Electromagnetics?
Digital. Okay. Okay. So, guys, in this session, we will look at the questions from digital electronics. Again, kind of the questions were kind of quite moderate in nature in terms of digital electronics. Questions are not very tough. Okay, there are a few questions which are directly asked from the classroom discussion that we generally do. Okay, so this is the one waveform based question. So even though this is a waveform based question, you can analyze it by means of the table. Okay, a counted table. So here I'll call this flip flop as nothing but 1 and this as 2. Okay, and here we have P naught. This is P naught and this is P1. And it has been mentioned to you that P naught is always equal to 0 and P1 is always equal to 1. Okay, and select line waveform is given to you, and also the clock is given to you, and given that all the flip flops are basically positive edge triggered. Okay, so this is also mentioned to you. So positive edge triggered flip flops. So the active edge of the clock is nothing but the rising edge of the clock. But they asked you what is the date of each of this circuit, or the value of y basically at each of these timestamps T0, T1, T2 and T3. Okay, and yeah, you have a few options. So all you have to do is nothing but construct the table. So the table consisting of, first of all, D0 as well as D1, okay, and then Q0 as well as Q1. Yeah. So and then Q0, Q1, And finally, on the basis of that, what is the value of y? If you look at what is y, y is XOR of q2 bar as well as, sorry, this is 0, this is 1 I have taken, no? This is 0, and let's call this as nothing but 1. So let us call this as 1. Okay, so this is flip-flop number 0, this is flip-flop number 1. So this is D0 Q0 and this is D1 Q1. Okay, and this is Q0 bar and this is Q1 bar, right? So finally, whatever is y for us, y is basically Q1 bar XOR Q0 bar. Okay, which is also equal to XOR with 2 complements is also equal to 1 more XOR, because 2 complements means even number of complements you are having. So this is also functionally same as Q0 XOR Q1. Functionally both are one and the same. Okay, so let us look at what are the values of D1, D0, and on the basis of that, what will be the value of Q0, Q1 at every timestamp. First timestamp, this is the active edge of the clock. At the first active edge of the clock, select line is nothing but 0. Select line is 0. Select line is 0. Whenever select line is 0, the connection is nothing but 0 to output, 0 to output. Okay. So at 0, what do we have? 0. And at 0, what do we have? 1. So D0, D1 becomes equal to here 0, 1. Because of that, after the clock, Q0, Q1 also becomes equal to 0, 1. Okay. So this is the value of Q0, Q1 after the first clock. This is just before the first clock and this is just after the first clock. XOR of 0, 1 becomes equal to 1. Okay. XOR of 0, 1 is nothing but 1. Next, second timestamp. At the second timestamp, the value of select line is nothing but 1. And the value of select line is equal to 1 even at the third clock also. At the second as well as third clock values, the value of select line is equal to 1. Okay. So whenever select line becomes equal to 1 now, we are taking the value of select line to be equal to 1. In that case, the connection is nothing but 1 to output. Whenever select line is 1, the connection is 1 to output. Here, 1 means S. What is the value of S? At the second clock, this is a second clock, the value of S is nothing but 0. The value of S is nothing but 0. So the value of D0 because of that becomes equal to 0. So D0 is nothing but 0. What is the value of D1? D1 becomes equal to whatever is Q0. And what is Q0? The present state Q0 is nothing but 0. So because of which D1 also becomes equal to 0. Okay. So since D0, D1 are 0, 0, Q0, Q1 also becomes equal to 0, 0. XOR of 0, 0 is 0. Okay. So this is after the second clock when select line becomes equal to 1. Yellow corresponds to select line 1 and green, let's say, corresponds to the select line being equal to 0. Third clock, again we have the value of select line 1. So same kind of connection. Okay. Same kind of connection means S value remains to be equal to 0. At the third clock, the value of S becomes equal to 1. S becomes equal to 1. So I'll take a 1 here. Okay. And what is the value of D1? Now D1 becomes equal to Q0. What is the present state of Q0? Present state of Q0 is nothing but 0. So here we'll have 0. Okay. So since D0, D1 are 1, 0, Q0, Q1 next state becomes also equal to 1, 0. Okay. And XOR of 1, 0 becomes how much? 1. Okay. And in the last clock, if you notice, the value of the last clock, we have, the select line being equal to 0 here. Okay. Select line 0 means connection is, 0 to output connection, 0 to output connection. And already at 0, both cases, what is being connected? P0 as well as P1, their values are always constant. That is what is mentioned to us, which is nothing but 0 here, 1 here. Okay. So which is again the initial case 0, 1, and hence output also becomes equal to after the clock 0, 1, and hence output y is XOR of 0, 1. XOR of 0, 1 is nothing but 1. So finally, if you notice, this is the value, the first one that you have, this is the value when at T0, and this is the value when at T1, this is the value when at T2, and this is the value at T3. Okay. So finally, T0 to T3 order, if you see, it is nothing but 1, 0, 1, 1. Okay. So that is what is asked for us. What is the value of y from T0 to T3? And the answer is nothing but 1, 0, 1, 1. Okay. So this is more or less a counter based question only, but rather you have been given timing diagram. Okay. So the question was looking a bit scary. So because which people might have felt that the question is a bit tough, but rather this is not at all a tough question, very easy question. Okay. Yeah. Next. See, this is one question that we generally discuss in the class also. I discuss it by using 4 XOR gates. Okay, 4 XOR gates, and I usually take a 4 input adder. Okay, so here whenever Z is equal to 1, okay, then what will happen? Z is equal to 1. Whenever for XOR gate one of the input is nothing but 1, so one of the input to XOR, let's say, is equal to 1. So in this case, XOR gate behaves as a NOT gate. XOR gate behaves as a NOT gate. Okay. So because of that, if the input is nothing but Y, the other input is Y, the output here is nothing but Y bar. Okay. Or I can say 1's complement of Y, because every bit in Y will be complemented. If at all you are having this as nothing but a 4-bit circuit, so in that case, yeah, all 4 of your Y's will be complemented. Okay. And anyway, Z is also equal to 1. So that is also given as full adder will have 3 inputs. The main inputs are nothing but X and here Y bar, and the last input is nothing but carry in. So this input by default becomes equal to carry in. Okay. So if you notice, what is the value of F, which is nothing but output of, what is the output of full adder? Output of full adder in this case is nothing but F. What is this F? F is equal to X plus Y bar plus 1. Okay. Generally, if you are having multiple bits in Y, so each and every bit individually is complemented there. So I can say that this is equal to X plus 1's complement of Y plus 1. 1's complement of a number plus 1 becomes equal to 2's complement of that number. So this becomes equal to 2's complement of, this is 2's complement of Y. So whenever you take a 2's complement of any number, that number will be a negative number. You take complementations only for negative numbers, not for positive numbers. Okay. So whenever you are doing complementation, the complementation is taken only for negative numbers. Okay. So because of which you can say that this is basically X plus minus Y. Okay. Because complementation is done only for negative numbers. X plus minus Y is basically what? This is basically X minus Y. X minus Y. So finally, even though you are having adder here, the circuit is performing subtraction. Okay. So the output of the circuit is nothing but, or the circuit behaves as basically what? Subtractor. Even though you are using adder, the functionality that is achieved here is nothing but subtraction. Okay. Yeah. Next question. Yeah, this is a good question. Again here, this is one model that we generally discuss in class in the topic of timing constraints. Okay. So there is AND gate whose delay is nothing but 1 nanoseconds. There is an AND gate here, and the clock to Q delay of flip-flops, this is obviously of each flip-flop, is nothing but 2 nanoseconds. Setup time is given as 2 nanoseconds. Hold time, this is basically hold time. Hold time is basically given as 0 nanoseconds. Okay, and then you are supposed to find out what is the maximum frequency of operation of this circuit. Okay, so here we always have to go for input to input delay. Input of a flop to input of the next flop. Okay, here I am having 2 paths. The first path is nothing but, if I call this as 1, this has nothing but 2. So when the data is going from 1 to 2, okay, so whenever you have multiple paths available, you have to verify for all cases. So this is one case that is present for us. One more is nothing but when data is going from flip-flop number 2 to flip-flop number 1. Okay, 2 to 1. So when data is going from 1 to 2, the path looks like this. So this is how the data is going. Okay, so in this, all you have is nothing but only flip-flop. There is no combinational circuit delay. And the setup time inequality, the general setup time inequality formula is nothing but T clock minus Ts should be greater than TPD FF plus TPD combinational circuit. Okay. To be more precise, when the data is going from 1 to 2, the formula when the data is going from 1 to 2 is nothing but T clock minus TS2, the second flop always, should be greater than or equal to, in fact, TPD of FF1 plus TPD combinational circuit when the data is going from 1 to 2. Okay, so this is a generalized formula and we can use it here. So in this T clock minus setup time, for both the flops setup time delays remain same. Only thing is combinational circuit from 1 to 2 and 2 to 1 paths are different. Okay. So t clock minus setup time is how much? This is nothing but 2 nanoseconds should be greater than or equal to TPD of FF1. What is the delay of the flip-flop number 1? Delay of the flip-flop number 1 is nothing but 2 nanoseconds. 2 nanoseconds plus. When you are going from 1 to 2, are you having any combinational circuit here? No. So because which this combinational circuit delay when the data is going from 1 to 2 is nothing but 0. So this is 0. Okay. So finally, t clock in this case becomes greater than or equal to 4 nanoseconds. So means F max when the data is going from 1 to 2 basically is equal to inverse of 4 nanoseconds. Inverse of 4 nanoseconds, if you take 1 by 4 nanoseconds becomes equal to, if I'm not wrong, 250 megahertz. Okay. So when you're operating at a frequency of 450 megahertz or smaller frequency, data can be properly transferred from flip-flop number 1 to flip-flop number 2. But that is not the final answer. You have to verify for other data paths also. The other data path that is available to you is nothing but when data is basically going from 2 to 1. So this is the path you are supposed to consider in that scenario. Data is going from 2 to 1 now along this path. Again, we will use the same formula. Now t clock minus setup time. What is the setup time here? Setup time again for both of the flops, it is nothing but 2 nanoseconds should be greater than or equal to TPD of flip-flop number 2 right now, because this is a formula for 1 to 2. When you take the formula for 2 to 1, the numbers will be reversed. Okay. So for the second flop, what is the delay? Delay is nothing but anyway 2 nanoseconds. 2 nanoseconds. And along this path, are you having a combinational circuit? Yes, we have a AND gate here. AND gate has a delay of 1 nanoseconds plus 1 nanoseconds. Okay. So t clock should be greater than 2, 2 and 1. It is nothing but 5 nanoseconds. And accordingly here, what is the value of F max in the second case? That is when the data is going from 2 to 1. This is 1 by 5 nanoseconds, which is equal to 200 megahertz. Okay. So this is 200 megahertz. So now, which of these I'm supposed to pick? You're always supposed to pick the smallest value possible here. Okay. Because see, if let's assume I'm operating at 200 megahertz, data will be properly transferred from 1 to 2 as well as from 2 to 1. But if I operate at 250 megahertz, okay, so then data will be properly transferred from 1 to 2 but not from 2 to 1. So you have to make sure that all the data paths are having a proper data transfer, and that can be possible only when you pick the smallest F max possible. You have to always pick the smallest F max possible here, and here amongst 250 and 200 the smallest value is nothing but 200. So this is our answer. Okay. So if you call this as F max number 1 and this as F max number 2, what is the overall F max right now? The minimum of both. Okay. So the overall F max is nothing but F max overall is equal to minimum of F max number 1 comma F max number 2. Okay, which becomes equal to 200 megahertz. Okay. So a same kind of a question, in fact slightly tougher question was asked in 2020 GATE paper, GATE EC paper. Now again we have got a repeated model. You can say now this is a repeated model. 2020 was definitely a tough question because there for 1 and 2 they have given different setup times, different hold time, different delays for both the flip-flops, etc. So obviously in that case it becomes a bit more trickier as compared to this question. This is definitely on the easier side. Okay. So let's go for the next one. Yeah. So here we have a weighted resistor adder. The reference voltage is nothing but 2 volts, and B3, B2, B1, B0 are given to you. And by the way, this resistance value is nothing but R. So given this data, we are supposed to find out what is the value of change in output voltage. Del V0 corresponds to, in the question it was given as change in output voltage. Change in output voltage. And you are supposed to express the answer in terms of millivolts. You have to express the answer in terms of millivolts. So if you notice, what are the decimal values of the inputs? So this 1110 corresponds to 14, decimal value 14, 1101 corresponds to decimal value 13. So how much is the change in input in terms of decimal number? It is only one single unit. Okay. So on the basis of this, you can say change in input. change in input is equal to 14 minus 13, which is equal to 1. So the meaning of this 1 is nothing but one single step size. Okay, so this is one single step size, or also known as 1 LSB. Okay, so the overall change that you're having is nothing but 1 LSB. Okay, so means logically, if you think, no, the question is very simple. You don't have to do the entire calculation. All you have to do is nothing but whenever I activate only my LSB, this is LSB for us. Whenever you activate only this LSB by switching off the remaining switches, okay, that is B3, B2, B1 are nothing but off. Only B0 is switched on. This switch is closed. Then what is the value of output voltage? That is what you are supposed to calculate. Okay, so this is also same as the value of output voltage V0 when B3, B2, B1, B0 becomes equal to 0001. Okay, so in both cases we will get the same answer. If you think like this logically, the time taken to solve this question will be very less. Okay, so let us do that. So this is open, this is open, this is open. So this entire part of the circuit is gone right now. I'm only taking this part of the circuit. Okay, this is op amp in negative feedback. So because which, what is the value of output voltage? Output voltage is equal to minus RF divided by the input resistance Rin into Vin. Okay, and this becomes equal to feedback resistance is nothing but R. So minus R by. So this Rin value is nothing but 8R in this case. 8R times Vin. The input voltage is nothing but reference voltage of 2 volts here. So into 2 volts. Okay, so that's it. This is your answer. So, and all you have to find out is nothing but only magnitude. Okay, you are supposed to find out in fact magnitude of change in voltage. So if you simply want magnitude of change in voltage, so I'll put a modulus here, and in the process, this is now R and R is gone. Now you have 2 by 8. 2 by 8 is nothing but 0.25. So this is 0.25 volts. But the examiner asked you in terms of millivolts. 0.25 volts in terms of millivolts would be how much? This is nothing but 250 millivolts. That's it. So a simple question. Again, I think this was asked for 2 marks in fact. So this is 250 millivolts. Okay. Yeah. Next. Okay. So a 10-bit ADC has a sampling frequency of 1 megahertz. Sampling frequency is given. And and the first thing you are supposed to calculate is nothing but what is the data rate. What is the data? What is the formula for data rate? Data rate formula is nothing but n times fs. N times fs, where n is nothing but number of bits in the ADC, which is nothing but 10, into sampling frequency is nothing but 1 mega. So this is 1 mega. Okay, so 10 into 1 mega is nothing but this is 10 Mbps. Okay, so this is the first part of the question, or one part of the question in fact. And then you're also supposed to find out what is the value of SNR. Okay, what is the formula for signal to noise ratio? This is 1.76. Okay, plus 6.02 times n. Okay, again in this case, what is the value of n? N is nothing but 10. So if you substitute that value 10 here, so this is 10. So this becomes 60.2 plus 1.76. When you substitute the numbers, we get the value as nothing but 61.96 if I'm not wrong. We get 61.96 exactly. Okay, so this is in terms of dB. Okay, and by the way, this is the formula for SNR in terms of dB. So 61.96, and data rate is nothing but 10 Mbps, and the correct answer in this case is nothing but 61.96 and 10. Okay, again this is a straightforward formula based question. There was one more question. In fact, one of our very favorite questions from classroom discussion point of view. We discussed that question many times. That is nothing but majority circuit. We have also a question on majority circuit. Okay, so examiner told you that there is something called as majority circuit. Okay, so in this majority circuit, the function f becomes equal to 1 when majority of x, y, z, which are nothing but inputs, becomes equal to 1, and f becomes equal to 0 when majority of x, y, z becomes equal to 0. Okay. So in this case, what is the minimized expression of f? F in minimized form. Or I don't remember whether it is in the minimized form or simply you're supposed to find out f, but ultimately you're supposed to find out the Boolean expression for f. Okay. So firstly, we can construct the truth table for this. Okay. So we have the inputs given as x, y, z. See, if you remember this in the classroom discussion, no, it will be very simple for you. Hardly this will take 15 seconds of time. All you have to do is simply identify the generalized equation for majority circuit. And first case, we have majority of zeros, output is 0. 0, 0, 1. Secondly, again zeros are in majority, output is 0. 0, 1, 0. Again zeros are in majority, output is 0. 0, 1, 1. Ones are in majority, output is 1. 1, 0, 0. Zeros in majority, output is 0. 1, 0, 1. Ones in majority, 1. 1, 1, 0. Ones in majority. 1, 1, 1. Ones in majority. Okay. So this is the function we have. Now you can construct the K-map for this. If you look at, there are 4 ones here, and what are these ones? This first one corresponds to. This first one corresponds to. This is minterm number 3. This is minterm number 5. Minterm 6. Minterm 7. Okay. So yeah, let's construct the K-map completely right now. So this is x, y, z, 0, 0, 0, 1, 1, 1, 0. Okay. So this is cell number 3, 1. Cell number 5, 1, 6, 7. So remaining cells are nothing but zeros. Okay. Now you have to form the grouping here. I can clearly see that there are 3 groups available. 1, 2, and 3. All 3 are pairs. Okay. And what are these groupings minimized as? So this is basically y into z. What about this? This is nothing but x into y. So this is xy. And lastly, this is basically xz. So this is xz. Okay. So we have our final answer now. What is the final answer now? Minimized form. It is nothing but xy plus yz plus xz. Final answer is nothing but xy plus yz plus xz. Okay. So generally, I teach Boolean algebra entirely in terms of this majority circuit example only. All forms we will discuss about this majority circuit in SOP, POS, minterms, max terms, truth table, Venn diagram, every format. So because of which, whoever attended my lectures, for them it will be very easy for them to identify this particular question. Okay, majority circuit is the wording exactly is what we use in the class also. Okay. Anyway, yeah, these are the questions we have from digital electronics. Kind of quite easy questions. The questions are not tough except for the timing diagram question. Yeah, certain people find that question a bit intimidating because circuit is given and then waveforms are given, and the moment you would see timing diagram, people are a bit scared. Okay, so because of that, the question is a bit intimidating for you. The examiner is trying to play with your mindset, but as such, the question is not tough. Whatever analysis we use in counters, same analysis we also use there. Okay, but only thing is you have to get the data from timing diagram. You're not getting the data from the circuit, but rather you're getting the data from always timing diagram. Okay, so that is the important portion there. Okay, yeah, we will now discuss EMT questions. So let us look at EMT questions. I think this question Gautam sir has discussed in EDC anyway. Yeah, this is one question that we have which relates to the power transmitted to the load. And surprisingly, I believe this was a 2-mark question. Okay, I believe this was a 2-mark question. Very easy question, not a tough question. Hardly it will take 1.5 minute of time, not more than that. Okay, so what is the power delivered to the load formula? What is the formula for power delivered to the load? Sometime guys. Okay, let's leave it. Coming out like that. Okay, let's leave it. Yeah. So what is the formula for power delivered to the load? The power delivered to the load formula is nothing but incident power into 1 minus modulus of gamma whole square. So already I have given the incident power, which is nothing but 10 milliwatt. So this data is given to me, which is nothing but 10 milliwatt. So in this question, all you are supposed to find out is nothing but what is the value of mod gamma. Okay. Okay. All we have to do is nothing but find out the value of gamma from the characteristic impedance of transmission and as well as the load impedance given to us. So what is the formula for gamma? Gamma is equal to ZL minus Z0 by ZL plus Z0. Substituting the values, we have 50 minus J75 minus 50 divided by 50 minus J75 plus 50. When you do the calculation, 50 and 50 is gone. We have minus J75 by 50 plus 50 is 100. 100 minus J75. If I divide with 3 both on the numerator as well as denominator, 25 both on the numerator as well as denominator, I get it as minus J3 divided by 4 minus J3. See, I don't have to find out the complex value of this. I only want the magnitude ultimately. This is the value of gamma. So from this, what is the value of mod gamma? What is the value of mod gamma? What is the modulus of numerator? Numerator modulus is nothing but 3. Denominator modulus is how much? Square root of 4 square plus 3 square. What is the value of square root of 4 square plus 3 square? It is nothing but 5. So this value becomes equal to denominator 5. So mod gamma became equal to 3 by 5. Substitute the value here. Then we will get 1 minus gamma square. 3 by 5 square is nothing but 9 by 25. 1 minus 9 by 25 is nothing but, so this is 16 by 25. Okay. And 16 by 25, if you do the calculation, you get it as nothing but 0.64. 0.64 into 10 is nothing but 6.4 millivolts. Okay, 6.4 millivolts. So finally, the answer here is nothing but 6.4 millivolts. Okay, a very simple question. In fact, I was surprised when I saw that this question is asked for 2 marks basically. This was a 2-mark NAT question, but rather a very easy question. Okay. Yeah, the remaining 2 questions surprisingly this year are from statics portion. Okay. One of the question is nothing but we have some kind of a sheet placed like this on XY plane, and the charge density, the surface charge density is given as 4 modulus of Y. And what is the units here for surface charge density? It is nothing but coulombs per meter square. Okay. And you are supposed to find out the total charge. What is the formula for total charge? Q. Q is nothing but integration of rho s ds. Q is basically integration of rho s ds. And if you do the calculation here, this becomes equal to, see here, the logic is nothing but on the top side, Y is nothing but positive. So here Y is nothing but positive. Okay. So means what is the value of 4 modulus of Y? This becomes equal to 4Y, and obviously a positive number. Okay. Rho is never negative. Okay. On the bottom side, what is the value of Y? Y is negative. But what is the value of 4 modulus of Y here? What is the value of 4 modulus of Y here? Since you are taking modulus value, all you get is nothing but only positive number. So this also becomes equal to positive. Okay, there is some kind of symmetry here. And furthermore, the value on the top side, the value for rho s on the top side, bottom side is positive only. So I can clearly see here that rho s here is positive and rho s here is also equal to positive. So I don't have to perform integration on top side separately and bottom side separately. I can perform the integration on only one side and multiply that value with 2. Okay, and furthermore, left and right also there is symmetry because the value of rho s is not a function of x. So because of that, I don't have to calculate everywhere. All I will do is nothing but calculate the value of charge only in the first quarter. Whatever value I get there, I multiply that with 2. Okay. So here, rho s. Now what is the value of rho s in the first quarter? In the first quarter, the value of y is positive, and because which the charge density rho s value becomes equal to 4y. So this becomes equal to 4y. What is the value of ds? On xy plane, ds is nothing but dx dy. So it's a double integral. So 4 I can take it outside. You are integrating dx. 1 dx integration is how much? X. What is integration of y dy? It is y square by 2. It is y square by 2. Now substitute the limits. Only in the first quadrant, x is varying from 0 to 2. This is nothing but line 2. So x limits are from 0 to 2. Y limits are from again 0 to 2 only in the first quadrant. But since you are doing the integration only in the first quadrant, you have to multiply the overall value with 4. Okay, overall value with 4 because of symmetry. Okay, 4 into 4 is 16. This is 16 into x. When you substitute the limits, this becomes equal to 2, and then 2 square by 2. For y limits, it is nothing but 2 square by 2. So 2 and 2 is gone. Okay, 2 square is nothing but 4. 4 into 16 is 64. Okay, 64. And all the units were in terms of microcoulomb basically. Even the value of rho s is given in terms of microcoulombs in the question. Okay, and the final answer, microcoulombs per meter square, is what is given to you in the data also. Okay, it was not mentioned here, but that is what is given in the question for you. And hence final answer is nothing but in terms of microcoulombs. So in terms of microcoulombs, the answer is nothing but 64. It's a MCQ question, but again 2 marks question, very simple question. Okay. Yeah, next. There was one more, question on Faraday's law. There was one more question on Faraday's law. I'll just write the question though. Okay. So there was a loop given to you something like this. There are two resistors. This is 2 ohm resistor and this is also 2 ohm resistor. The area of this loop is given as 5 meter square. So this is again EMTL question based on Faraday's law. This is a very simple class 12 question. This is not even a GATE BTech level question. This is basically an intermediate question. Okay, class 12 question. And you are supposed to find out what is the value of induced current in this particular loop. Okay, so current induced in the loop. Okay, in the loop is equal to dash. I think you have to get the answer in terms of amperes. And furthermore, you have been given due to magnetic field B, which is given as 0.5 times T. Okay, Webers per meter square. So this is also given. Okay, so what is the formula for induced current? The current induced is nothing but induced EMF by resistance value. So this is nothing but current induced becomes equal to, this is basically, so this becomes equal to induced EMF by resistance value. And how much is induced EMF? Induced EMF formula is nothing but minus d phi by dt divided by resistance value. Here you are only supposed to find out the magnitude of current induced. In the question it was very explicitly mentioned that current magnitude. Okay, all you are supposed to find out is nothing but only the magnitude. It was very clearly mentioned that you are supposed to find out only the magnitude. So sign part I don't bother. So what is the phi? Magnetic flux value is how much? Flux density into area. So this is the B times A into d by dt. Okay, divided by how much is resistance value? Resistance value is nothing but 4. So this becomes equal to, area is a constant value which is 5. So this is area is 5 divided by 4 into d by dt of B. B is given as 0.5 times T. So this is into 0.5. Differentiation of 0.5 T is nothing but 0.5. So finally all you have is nothing but 2.5 divided by 4. And if you do the calculation, you get it as nothing but 0.625 amperes. Again, this was also asked for a 2 marks question. This is hardly this is a 1 mark question, I would say, and this is an intermediate level question. This is not even a BTech level question, but rather the examiner gave you the diagram and made the question look a bit big. So because which it may be a bit intimidating, but rather if you read the question properly, not a tough question. Okay. So yeah, these are the questions from. Done, sir. I'm done. Yeah. So these are the questions you have in EMTL as well as digital. Okay. Yeah. So next, Rakesh sir will be taking the classes questions. Sir, which topic you will take?
Signals, control, maths, aptitude.
Yeah, the remaining questions of signals, controls, maths, and aptitude. Okay. Yeah.
Okay. So yes, guys, moving ahead. So, some more signals, controls, and aptitude question. I think there are two more maths question that are not typed here. First, I'll finish them and then we'll go to controls and signals question. Maths already we discussed earlier. Okay. Two more questions I've got that is actually in mathematics. So that there is a question series. Heman sir, there is one question of series convergence. That is in maths? Okay. That is a basic logic. Whether you put in maths, aptitude, anywhere, it's a very basic logic question. Okay, so let me just go to that series once.
But sir, that question is like only one is correct, only three is correct.
Okay, like that. That options are there. I'm just going to that question. Yeah, here is that. Okay, dear. So, basically, there are, three series given to you. Mathematics, 1 mark, MCQ. Okay. So, there are series given to you. What I feel, students, the paper is more or less easy to moderate side. I mean, for students, it can be maximum up to moderate. There is no difficulties as of in most of the questions, I would say. Okay, only few questions can trouble you. But what is the tricky part for today paper? Lot of MSQ questions are there with single option correct. And that is your patience tester in the exam time. Okay, there have been, several MSQs, but only one option correct. I think 3-4 till now I have seen, right, Heman sir? Yes. So that is what maybe, might have killed some of your time, ki MSQ, but why only one option correct? That area under the graph, correct. That question also I have, no, mathematics, correct. Yeah, I'll discuss that also. Okay, so consider the following series. There are three series given to you, summation 1 to infinity. Okay, 1 by root n. Second case, summation 1 to infinity, 1 by n, n plus 1. And third is summation 1 to infinity, 1 upon factorial n. Okay. Two of them you can solve by the very basic logic. Question is which of them converges. Okay, I'll write down the option. Okay. Which of these series actually converges? Okay, so we have the option number A as only 2, option number B as, option number A as 2 and 3, option number B as only 2, option number C as only 3, And option number D, all will converge. All will converge, correct. Now see dear, let me start with the easiest one. See, for all of them, you can apply the convergence criteria, but third one, okay, what is the third one? 1 upon factorial n, okay, that is 1, okay, summation 1 to infinity. Okay, so 1 upon factorial 1, 1 upon factorial 2, 1 upon factorial 3, isn't it? So can't you convert to exponential? This will convert to exponent number. Why? Because e power x is 1 plus x upon factorial 1 plus x square by factorial 2, etc. Okay, so if I put x equal to 1, only thing is it's not 0 to infinity, but doesn't matter. Okay, this much. If I put x equal to 1, okay, I'll have e power 1 and subtract 1 on the other side. So this is converging. It gives a finite answer, e power 1 minus 1. So you can solve it by that logic. Okay, otherwise, you know, you have the convergence test that can be applied. Second one, you know, if I talk about the nth term, is 1 upon n plus 1. Okay, you know, normally, which I call it as the Tn method, 1 upon n plus 1, okay, which can be split into the partial fraction, and it can be split as 1 upon n minus 1, 1 upon n minus 1 upon n plus 1. Okay, so if I write down the several terms of the series, now what is the first term? 1 by 1 minus 1 by 2. What is going to be the second term? 1 by 2 minus 1 by 3. Third term, 1 by 3 minus 1 by 4. Nth term, 1 by n minus 1 by n plus 1. Okay, so when you take the sum of these terms, dear, you just see here, na, when you take the sum, minus 1 by 2, 1 by 2 cancel, minus 1 by 3, 1 by 3 cancel. Okay, similarly, this 1 by n will be cancelled with the previous term. Only what is not cancelled is 1 upon 1 minus 1 upon n plus 1. Okay, and for n tending to infinity, sum up to infinite, na, summation n equal to 1 to infinity. For n tending to infinity, Sn will be 1 minus 1 by infinite. Okay, and it converges. Finite value, it converges. Okay. Okay, so, you know, 2 and 3 converges, but whether all converges, 1 upon root n. Okay, 1 upon root n. Okay, now let me come to the first one. First one, the nth term is 1 upon root n. Okay, now, you know how you can evaluate this one. So let's basically take, you know, the simplest ratio test here. Okay, what is the ratio test? Take the ratio of the, you know, suppose if the series is extended beyond nth term, what is the ratio of the two consecutive terms? Okay, for large values of n, an plus 1 upon an. Okay, an plus 1 will be 1 upon root n plus 1 divided by 1 upon root n. Okay, divided by 1 upon root n, and which is simplified as 1 root n upon n plus 1. Root n up, no. Ratio test will fail here. We'll go by integral test because ratio test r will be 1. Forget. Okay, if this is an, let's call it as some function fn then. Okay, now what is integral 1 to infinity fx dx? Or if you make it as a x function, what is this integral 1 to infinity? So we have to solve it by the integral test. Okay, so 1 to infinity 1 upon root x dx. Whether this will converge or not, we'll see. 1 upon root x, that is x power minus half. So, you know, I'm solving it as x power half upon the integral value will be x power 1 by 2 upon 1 by 2. Okay, but x power positive. In the numerator, you have got x power positive. So when you are going to put the upper limit infinity, it's going to be unbounded. Okay, so the first series will not converge. Okay, because the integral 1 to infinity fx dx not converge, the first series will not converge. It is divergent. Okay, it is divergent. Okay, similar test can be applied to second and third, but I believe second and third are more logical in nature that you can solve by basic aptitude. So I have solved it that way. Okay, so the correct answer is option number A. Okay, second and third series will converge. The second and third series will converge. Okay. Okay, next one. So what is there in the next one? One more mathematics question. Have a look into this. Yeah, it's on expectation. So basic question on expectation. Okay, marks are not written, but yeah, it's a NAT question. Okay, two fair dice. Two fair dice with the faces 1, 2, 6. Okay, are rolled. These are rolled. Okay, let the random variable x. Let the random variable x, okay, denote the sum of the outcomes. the sum of the outcomes obtained. The sum of the outcomes obtained. What is the expectation of x? Okay, the expectation of x is how much? Okay, expected value. You see dear, no need to solve it by any lengthy formula. No need to solve it by any lengthy formula. Okay, first of all, if I talk about the sum, what are the possible values? Sum on that, two dice are tossed. The minimum sum is 2, 1 plus 1. Okay, then next would be 3, next would be 4, 5, 6, 7, 8, 9, 10, 11. The largest sum is 12. Okay, that is, 6 plus 6. That is the largest possible sum. Now, dear, how many cases will be there? Okay, or if I write down the probability, okay, for each value of the sum. So see, 2 can be obtained as only one case, 1 comma 1. Okay, only one case and probability 36. 3. Now, as you keep moving right, number of cases will increase up to a certain point. How can you get 3? 1, 2 and 2, 1. There will be 2 cases. Okay, 4. Okay, 1, 3. I'm not writing the cases. You can listen orally. 1, 3, 3, 1 and 2, 2. So there will be 3 cases. So dear, the pattern is such that it will keep on increasing. It will keep on increasing. Okay, up to the sum being 7. Okay, up to the sum is 7, you will get all 6 cases. Why? Because 1 comma 6 is there. Okay, 2 comma 5, 3, 4, 4, 3, 5, 2, 6, 1. All 6 cases will come. But as soon as 8 will come, now again you cannot take 1. To make the sum 8 minimum, you have to have 2 on one dice, 2 comma 6. If you take 1 on any one dice, sum cannot be obtained. So one case is reduced. Again 5 by 36. Similarly, you keep doing. Next will be 4 by 36. Next 3 cases will now reduce. 2 by 36 and again last is again 1 by 36. Why? Because 12 can only be obtained as 6 plus 6. Only one case. But point is, how do you find out the mean? That is important. How do you solve this expectation question? There are two things. Okay, summation of x into PMF. Okay, or very simple logic. Very simple logic. Don't you see that this distribution is symmetric? Then your answer is there. Don't you see that this distribution, either you solve by this, you do some, multiplication and addition, but you see that the probability is 1, 2, 3, 4, 5, 6, 6, then again 5, 4, 3, 2, 1. Okay, so if you see a symmetric distribution, if you have a symmetric distribution, okay, then it is symmetric about what point? It is symmetric about 7. Okay, this is the center point. The left and right values are identical. Okay, so the expectation will be 7. Directly you can say. Okay, you can save time in such cases. Otherwise, if you solve summation x into PMF, then also it should be 7 only. You can try that. It has to be 100% 7 only. Okay, dear. Chalo. So I think, earlier I discussed 4, 5. These are 2 questions. One more question is there from mathematics. So, fx is a bounded function. Okay. In the interval 2, 8. Okay. And let small m be the minimum value and capital M be the maximum value, and then there is some relation given to you. Okay, alpha less than equal to integral 2 to 8 fx dx. Integral 2 to 8 fx dx less than equal to beta. Okay, question is, for what values of alpha and beta the above relation is always true? Okay, the above relation is always true. Is this what is the question, sir? Correct? Na? Yeah. And there are some 4 options which I have not got exactly, but no problem. We can discuss the theme of the question. There are some 4 options which is not available, but see what they are asking. Okay, integral 2 to 8 fx dx, and fx is clearly mentioned as a bounded function in this interval 2, 8. And what is this integral 2 to 8 fx dx? Okay, area under fx. Okay, area under fx. Okay, now what is the minimum value of the area? What they are telling, this area always belongs to alpha and beta. For what values of alpha and beta? Some 4 options will be there. Okay, but what you can see, what is the area under fx? Okay, the minimum will be, you call it area, or if you simply solve by the logic of integration also, anything is okay. Okay, so there will be 2 cases. It will be minimum if fx equal to m. M means, see what they are telling, let small m be the minimum value. So the function will take some minimum value. What I am assuming is, let's say function throughout the given interval takes the value small m. We can assume that, na? Okay, because any bounded function we can assume. Okay, so if fx equal to m for x belonging to the complete interval 2 comma m, and this is going to be maximum if fx equal to capital M. What is the next thing I can assume? That let us suppose that fx is any bounded function I assume to be constant capital M value. Okay, constant capital M value for all x belonging to 2 comma 8, isn't it? Okay, so what is the minimum and maximum value? Okay, so this minimum value, the integral minimum value will be, okay, so this m constant integral 2 to 8 dx will be 6. So 6m, and max value, okay, will be capital 6m. Okay, so now there are some four options given: alpha equal to 5m or beta equal to 6m or 7m, something like that is given. You have to choose alpha and beta such that, okay, you know, what you know now, the minimum value of this integral should be between 6m to 6m, a small m, capital M. Okay, so whatever the options are there, you can choose accordingly. Options I don't have, but you know, at least we have discussed the theme of the question. This was one question, right? It was MSQ. Because possibilities are there, na? Okay, because what you need to ensure is the there is only one correct. So this we have seen even in you know, control systems and other areas. You know, MSQ, but one option correct.
Not wrong, the correct answer is alpha is 5 small n.
Okay, acha, there is one option. Okay, it is MSQ. Okay, but one option correct. Okay, the correct option.
Alpha small 5.
Okay.
Beta 6 cap.
Yeah, works, because you know, minimum value it has to be, so alpha can be 5m, correct, because this integral according to us, see, according to us the integral is between small 6m to capital 6m. Okay, so alpha beta has to be a subset of this.
For two options, alpha is 7m.
Not that's what, na, alpha beta has to be subset of this. That's what.
Alpha is 7m.
And
for D, alpha is 6m.
Okay.
But beta is 5.
Fine, that's not correct.
Yeah.
So that is what, dear. This is the correct option. Okay. Option C, whatever it is, A or B. But yeah, this is what you have to see, that you know, alpha beta should be in this range. That's what you can say. Less than, and beta should be greater than. Chalo, let's move ahead. No, I have talked about the range of this one. I've given the, not the answer, the integral value. The integral value will be between 6m to capital 6m. Na? Okay, so beta of course can be, what I'm telling is here 6m can be there, here capital 6m. So of course alpha is less and beta is greater. Yeah. Okay guys, next question. So these are 3 more mathematics question discussed. I think straight away let me jump to aptitude and then come to signals and control. Okay, let's in the flow take the aptitude as well. Okay, yeah, verbal, you know, even if you know very fundamental grammar, you can just read an answer. Okay, had I learned acting as a child, I, okay, dash a film star. I could have been a film star. Answer has to be B for this one. Answer has to be B for this one. Correct, dear? Next question. Number 2. Okay, so number 2, one more verbal question. I'll jump to it first. Okay, so you know, there is a sequence given: abuse, insult, ridicule. Okay, abuse, insult, and ridicule, which is, you know, I would say decreasing order of expression. Okay, ridicule someone, insult someone, and abuse someone. That is extreme. Okay, now opposite is there: appreciating someone, praising someone, and the correct option for this will be extol, which means praising enthusiastically. Okay, so reverse, it has to be increasing order of the expression. Okay, so this was one more verbal question we have got. Yeah, come to this note. Okay, so the 12 musical notes are given as C, C hash, D, D hash, etc. Some 12 notes are given to you. Frequency of each note is 12 root 2 times the frequency of previous note. Okay, okay, if the frequency of note C, that is the first one, is 130.8, doesn't matter, it is suppose F. It is the frequency F. 12th root 2. Okay, this is, I'll write down this data. Frequency of each note is, sorry, not OC, frequency of each note is 12th root of 2, okay, times the frequency of previous. And if the frequency at note C is suppose F, then what is the ratio of the frequency of the note F hash and C? Okay, so F hash, how many terms you have to see? This is the first term, so second, third, fourth, fifth, sixth, and seventh. Okay, so basically what is going to be the frequency here? Every next term, okay, every next term will be multiplied by 12th root of 2. Okay, so how many next terms are there? 1, 2, 3, 4, 5, 6. Okay, so 12th root of 2. This factor will be multiplied 6 times. Okay, this will be the frequency into f divided by, comparing with C, only the C frequency is f. So f cancelled. It is going to be how much? 12th root, that is 2 power 1 by 2. Okay, so total 2 power 6 by 12, I would say, or that is 2 power half, under root 2. Under root 2. As simple as it could be. A GP question basically. As simple as it could be. Okay. Right. Okay. Yeah, there is another one question. Okay, which is actually easy. But only thing is, it looked like, here I have written the question in brief. It looked like a passage based question, and that may be the reason some students would like to skip it. But it's actually very easy. What is the theme of the question? There is a company which charges some consultation fee and some overhead. If the consultation fee is below 500, then the overhead is 20%. And if consultation fee is greater than 5 lakh, overhead is 1 lakh plus this is 10%. Okay, 1 lakh. Okay, plus 10% of the difference of the consultation fee and 5 lakh. Okay, what I mean is, suppose 6 lakh is the consultation fee. Then how much is the overhead? Okay, what is the difference between 6 lakh and 5 lakh? 1 lakh. So 10% of 1 lakh plus 1 lakh fixed amount of overhead. If also 18% tax applicable to the total amount, and customer can pay a maximum of 10 lakh, what is the maximum consultation fee? What is the maximum consultation fee? See, customer can pay 10 lakh. Clearly the amount is in the range of 10 lakh. So definitely the second case should be applicable. Consultation fee greater than 5 lakh. Okay. So let us say the consultation fee is C. Some consultation fee C. Okay. But because it is above 5 lakh, there will be overhead. What is that overhead? Okay, 10% of the difference of fee and 5 lakh. Okay, so C minus 5 lakh. Okay, C minus 5 lakh and 10% of this, and 10% of this plus 1 lakh. Plus 1 lakh. I'll write it in L only. Okay, and then 18% tax applicable to it. So into 1.18. Okay, this is the total amount. Okay, I would say this is the total amount. Okay, so if you want the total, maximum total amount of 10 lakhs, okay, then what is the equation turning out to be? C. This is C. This is 0.1 C. So total 1.1 C. In terms of C, I would say 1.1 C. Then this is 50,000. 5 lakh into 0.1. So 50,000. Okay. Plus another 1 lakh. And then whole multiplied by 1.18. Okay. This has to be equated to 10 lakhs. This has to be equated to 10 lakhs. Okay. So 1.1 C and minus 50 plus 1 lakh. So that is plus 50,000 is equal to 10 lakhs divided by 1.18. Rest is calculations. Rest is just calculation. So I'll do that calculation part, how much it is. Okay. And then to be subtracting 50,000 that side, finally dividing by 1.1. So some 7,24,000. 7,24,961.48. 724,961.48. 2 mark question. Question was this one only, na? Correct? Same question, na? And some options will be there around 720. Ha, correct. 72496. Ha, correct. This option is there. It is 2 marks. And aptitude means MCQ only they are asking every time. So that is also okay.
Plot of minus mod x by x.
Okay, in aptitude. Okay. Plot of minus x. Negative of signum function, dear. We represent mod x by x as, you know. So one more GA question. Sir, 1 mark, 2 mark? It has to be 1 mark, I think. I think it should be 1 mark, but okay. Yeah. Minus of mod x by x. This is what you're telling? Okay. Dear, at least EC students or EE students can understand this as negative of signum function. Okay, or if you don't want to go into signum function, no problem. It is minus of what? If x is positive, mod x is x, so x upon x 1. So what is left is minus 1. And if x is negative, mod x is minus x. So minus cancel, it will be plus 1. That's what I'm telling, negative of signum x. Okay, some 4 options will be there. Right side it has to be minus 1, left side it has to be plus 1. That's what the answer should be. Okay, dear. Yeah, so we got one more aptitude question. Okay, so now let's move towards the signals and control question. Okay.
Good question. I will give you the data. So there is iteration 1.
I've got this question, but roughly I got. So I did not. Okay.
iteration 0.
Huh.
Iteration 0, we have a line.
Okay.
The length of the line is 1.
Okay.
And then iteration 2. So the iteration 1. So this is the
Okay. A pulse given.
pulse. This is 1 by 3. Length of each individual line is 1 by 3.
Okay.
So length of each individual line is 1 by 3. And iteration 2. It was a bit complex. Each section was having the same shape.
Okay.
So
Got it.
This line was shown something like this. This line again, same diagram.
Length of each line is 1 by 9 given?
1
Or?
by 9.
Okay. And I got the question. Total 25 lines given?
25.
Ah. I got the data, but not in the form of diagram actually.
Yeah. So here, length of each line is 1 by 9.
Okay.
So you have to express the length of the entire diagram. It's
Nth.
a spatial aptitude question.
Got it.
So the length of the
In the nth iteration.
Nth iteration.
Nth
So this is
iteration.
iteration
0. We have to count from
so this
0.
is very important.
Okay. Yeah. So, dear, if you go to the iteration and see what is the pattern here, what you told total length. Total length. So, dear, if I talk about total length, let me make the case here. This is simple only, I think. Here, total length is 1. But what about the case here? 1, 2, 3, 4, 5. 5 segments are given. Each of length 1 by n. So, this is 5 by 3. Okay, this is 5 by 3. Now, here, okay, 25 lines are given, correct, sir? Okay, so there are 25 lines. Yeah, that's what. Exactly whether it is 25 drawn here or not, but in the exam it was 20. Acha.
They don't have to, should not count.
Huh.
They have to understand the logic. That
Correct. Each section.
is divided into
5 parts, right? And then the length of each here is 1 by 9. Okay, which is pretty much again, dear, which is pretty much 5. We can express it as 5 by 3 square. Okay, and if this is 5 by 3 square, the first term let me express as 5 by 3 power 0. So if you get this 5 by 3 power 0 for 0th iteration, for first iteration power 1, second iteration power n. So for nth iteration, it is going to be 5 by 3 power n. Correct?
2 marks MCQ.
2 marks MCQ. I got to know that there is some iteration question, but exact data was not available. Okay, correct, dear, correct. Okay, yeah. Chalo. So now I think let's move towards signals and some remaining questions of control. Okay, so consider a continuous time signals MCQ question. Okay, basic understanding of Fourier transform. Okay, and even if you have noted any time how Dirichlet's condition is derived, then you might be able to get the clear idea. Otherwise, simply we can solve. What is f omega? What is the Fourier transform formula? It is integral minus infinity to infinity ft e power minus j omega t dt, right? And okay, we have to compare modulus of f omega. Okay, greater than, less than we will see separately. But yeah, we have to compare with integral ft dt or integral mod ft dt. Okay, I think in one of the option it was less than, not all options were having equal to. Okay, but I'll tell you the correct answer, no problem. Okay, I think one of the option is not typed here correctly. But dear, see, what is the modulus of f omega? All options are talking about magnitude of this. So when you take the magnitude, let me apply the magnitude on which one? Okay, no problem. I'll tell the correct answer to the student. I think that correct answer is available with me. Yeah. So see, dear, let me apply the modulus to both the sides. So it is modulus of integral. Okay. And dear, modulus of integral or modulus of summation, anywhere you take, you know the mod of a plus b less than equal to mod a plus mod b. Similarly, modulus of integral is always less than equal to integral of the individual mod. Okay. Integral minus infinity to infinity, integral mod of ft e power minus j omega d dt. Now, one last thing you have to see. What is the integral of e power j theta is always 1. So, what will be only left is integral ft dt. Okay, what will be only left is, this is integral ft dt. Okay, so what is the final condition? See, mod of f omega less than equal to what? Less than equal to integral mod ft dt, and hence option number 3. Okay, option number 3. Correct, dear? This is the correct answer. Even all options may not be correct, but yeah, we have one correct option. So I have understood the theme of the question. Next question, dear. Okay, yeah, this is a decent question, I would say. Not difficult, but yeah, this is something where you have to apply a little bit logic. Though consider discrete time system below with the input xn and output yn, and in the figure h1 and h2 denote impulse response of LTI subsystems 1 and 2 respectively. Dn, sorry, it is not dn, it is del n. Okay, it is del n, which is the unit impulse, and b greater than 0. Assuming h2n not equal to del n, okay, the overall system, okay, which is denoted by the dashed box, okay, is what? Linear or time invariance, you have to check. Okay, so dear, okay, there are two subsystems. Okay, H1n and H2n are the impulse response of the LTI subsystems. Important is the subsystems are LTI. Okay, so if I write down the output at this node, if I have to write the output as this node, what is the output of any LTI system? Xn, convolution with impulse response, that is H1 here. Okay, now this is to be added with B del n. Again, dear, there is a correction. This is del n. Okay, and this is also del n. This will be added and then further convoluted with H2 to get the final output Yn. Okay, so dear, let me directly come to the output Yn equation. What is the output Yn equation? Okay, it is here. What is this signal? Okay, what is this signal? What is the input here? It is coming from there. X of n convolution H1n. Okay, xn convolution Hn. Okay, then to be added with B del n. Add B del n. Okay, I have done it. Add B del n and then convolute with the impulse response of the second system. So convolution H2n. Okay, then add with minus B del n, or that is subtract B del n. Okay, what you get is the output Yn. This is the equation. Done. This is the equation. Let me simplify, and for a moment, okay, for a moment, to be simple, let us say H1 convolution H2 is some impulse response H. Okay, so what is the final? Okay, it is Xn convolution H1 convolution H2 I have called as convolution as some signal Hn. Okay, then del n convolution H2n, we know it is H2n. Any signal convoluted with impulse will replicate the signal, and minus B del n. Okay, see dear, one thing that you must know, if there is a direct time function coming, okay, if there is any time function coming, right, in the input output relation, okay, if there is any direct time function coming like H2n will have some time function. Let's suppose H2n is a power n un. Okay, that is a time function. So other than input, if there is any separate function of time coming up, the system has to be time variant. The system has to be time variant. Okay, so separate time terms. It's not an input term. Okay, but yeah, separate time function coming. Okay, the system will be time variant. Now, whether it will be linear, not at all, because okay, suppose if I take an input, if I take the input, this is the output for input xn. If I take input, suppose 4xn. Okay, if I take the input 4xn, okay, what is the output? Okay, suppose this is some input x1n, 4xn. What is the output then? What is the output in that case? It is going to be 4xn convolution hn. Okay, but plus that term will not change. That term will not change. bh2n minus b del n. Okay, so is this output y1n input? See, if a system is linear, it should follow additivity and scaling. I have taken the simple case scaling. You can try with additivity also. Okay, if the input is 4xn, output should also be 4yn. Okay, but is it equal to 4yn? It's not 4yn. The 4yn will come if you take 4 common from here. But no, there is no 4 factor here. There is no 4 factor here. Okay, so scaling failed. System is non-linear. Okay, so the system, this is a good question, I would say. Non-linear and time variant, option number 3. Non-linear and time variant, option number 3 it is. Is that clear, everybody? Okay. Okay, fine, dear. Let's move ahead to the next question then. Let's move ahead to the next question then. Okay. So, yeah, next question in signals. Okay, guys. So, yeah, before that, please be updated that 23rd Feb, now your exam is done, and if you want to prepare for GATE again, or if your juniors or colleagues want to prepare, 23rd Feb, the next, okay, the online live course for GATE 26 or GATE 27 starts. The fees and details are mentioned here, and this is the next question of signals. Okay, so let xn be a discrete time signal. Very simple MS2 question, but very, very simple. Okay, xn be a signal with the z transform xz, which of the following is true? DTFT will always exist? No. Look into the C option then. DTFT exists if ROC contains the unit circle. Perfect. This is what we know. Okay, DTFT is the value of z transform evaluated over the unit circle. Okay, mod z equal to 1. Okay, now ROC of xz contains neither pole nor zeros. ROC cannot contain poles. Zeros, maybe there, may not be there. That has no connection with ROC. Okay, so this statement in general is false then. Okay, ROC does not contain poles, that is correct, but neither pole nor zero. No, ROC can contain zeros. Who stops? If xn equal to a del n, if xn equal to a del n, okay, sorry, alpha whatever, some constant alpha del n, where del n is the unit impulse and alpha is the scalar, ROC is the entire z plane. Why not? Okay, because what is the z transform? Del n z transform 1. So z transform xz is equal to alpha. There are no poles. There are no poles, and hence ROC, if there are no, ROC is bounded because of poles, na. ROC is always defined for this function. It is entire z plane. The correct answer is 4. Okay, so 3 and 4 are the correct answers. 3 and 4 are the correct answer. Okay, next question here. Okay, before the next question, also please note that for GATE 26 EEC, you can also have the online pre-recorded lectures so that you learn anywhere and at any time. Okay, these are the different modules, 3 months, 6 months, and 9 months and 12 months validity option. Okay, you will get it at OM Online Plus app. Okay, and you also have the online pre-recorded courses for the AE. If you're preparing for Transco, Discoms, any such examination with 3 months, 6 months, and 9 months validity module available for you. Right. Yeah, so next question of signal and system, again a MSQ one. Okay, again a MSQ question. Let FT be a periodic signal with the fundamental period T0 positive and consider the YT is equal to F of alpha T where alpha greater than 1. The Fourier series expansion on FT and YT are given by, okay, these are the basic Fourier series format. Okay, see now, the question is whether the fundamental period will change or not. Okay, and what about the Fourier series coefficient? Okay, time scaling property. F of alpha T. Alpha greater than 1, less than 1, doesn't matter, results will be equal even if alpha less than 1. Alpha greater than 1 represents compression here. Okay, YT will be periodic, 100%. It is just a case of compression. Okay, periodic waveform, even if you compress, remains to be periodic. What will compress? Time period will compress. Okay, time period will compress. Okay, so the time period will be, if the original time period is T0, it will be T0 by alpha. Okay, suppose if you write it as f of 2t, f of 2t means compression by 2. If you compress by 2, time period also divide by 2, t by 2. It's T0 by alpha primarily. And Fourier series coefficients, the scaling doesn't affect the Fourier series coefficients. Okay, so Ck equal to dk. Ck equal to dk. So 3 correct and 2 correct. Dear, GATE 2017, I think mostly 17 only. Same, not the same word to word, but exact similar model. Exact similar model they have asked in GATE 17. Okay, with respect to time scaling, okay, there was some signal x3t. Here they have mentioned alpha, there was clearly some scaling factor x3t. Okay, and the options were something like that, whether the Fourier series coefficient will change or not. Okay, angular frequency. Here they have asked in terms of time period. In that question, it was in terms of frequency. So if time period divided by alpha, frequency multiplied by alpha, right? So, that is why PYQs will help you a lot. Okay, PYQs will help you a lot. Okay, marks I have not got actually, what to say, don't remember. I have not got the marks for this, but yeah, in case, if you know the marks for it, please, if anybody knows the marks for it, please let me know. Please let me know. All right, control system. Okay, control system. Okay, good question. Okay, good question. Okay, so, there are 2 more questions from control system. Okay, and I think there is one more question of control system students are telling from RH criteria, but we haven't got it. Okay, yeah, before I come to it, let me take a simple question. Better, let me take a simple question of control system. One of the straightforward, I would say. Very, very straightforward. Okay, yeah. What is that question is? There is one question of Nyquist plot. Almost again, direct notes question or direct PYQ also you can say. Okay, so what is given to you? A Nyquist plot is given to you. Okay, a Nyquist plot has been given to you. And the mirror image case is also given to you. This is what the rough question we have got. Okay, you can let me know if there are any changes. Okay, and also what is given to you is the unit circle. Also what is given to you is unit circle, and there are 4 points given to you. Okay, there are some random 4 points given to you. P, Q, R, S. Okay, and this is the unit circle mentioned. Okay, correct. This is what is the question I've got, and you have to identify what? you have to identify omega GC and omega PC points. You have to just identify the points, the gain crossover point and the phase crossover point. Okay, so and there are 4 options, okay, which is not exactly not available, but yes, what is the omega GC? When the Nyquist plot intersects the unit circle, so that is S point. Where is the omega PC? Where the Nyquist plot intersects the negative real axis, that is the Q point. That is the Q point, as simple as it could be. Okay, how students were telling control system tricky? It's not tricky. Yeah, one question is good. Okay, that also not difficult. You know, logically you can solve this question. Okay, logically you can solve this question. Okay, so consider a system where x1, x2 and x3 are 3 internal states and ut is the input signal. The differential equation governing the state are given by, okay, governing the state are given by, okay, so it's a DCF model given to you. It's a DCF model given, but they are not asking which state is controllable or not. They are asking that there exists a bounded input such that the signals x1, x2, x3, which are the internal states, which of the states would be bounded or unbounded? That is what is the theme of the question. Now see here. Look into the A matrix and decide the poles. Okay, the poles of system. Okay, the poles of system equal to, because it's a DCF form, na? It's a DCF form. The poles of the system are directly the diagonal numbers, that is 2 and minus 2 and 0. 2 and minus 2 and 0. This element was not known. Okay, if it is DCF or maybe upper triangular. Okay, let me assume it to be DCF only right now. Okay. Okay, so 2 and minus 2 and 0, and definitely there is a RHP pole, so the overall system is unstable. Dear, overall system unstable means what? Overall system unstable means what? If there is a bounded input, okay, for some bounded input we can expect an unbounded output, but they are not talking about the output, they are talking about the internal states. Now dear, very logically you see what is the state corresponding to the RHP pole. Okay, what is the state corresponding to the RHP pole? Okay, what is the RHP pole? The RHP pole is at 2. Okay, and what is the state corresponding to it? X1. Okay, X1T is 100% unbounded. I'll tell you the reason also why it is unbounded. See, let's go to the mathematics of this. If you open the differential equation, the first differential equation, d by dt of x1 is equal to, okay, twice of x1 is twice of x1 plus the input term u, correct? Plus the input term u. Fine. Okay. Now dear, what we know that whenever there is a RHP pole, it gives a exponentially increasing term. That's what we know, na? Let's see this once again. So if I take the Laplace transform here, okay, if I take the Laplace transform here, s into xs, okay, minus some initial value x0, okay, let there be some initial value equal to 2 into xs, x1s, okay, plus input u, assume the input to be step, okay, assume step. I am assuming it is not given, but I can assume any bounded input. I have assumed step. But dear, when you get x1s from here, see what is going to be the x1s. Okay, x1s, s minus 2 common equal to x0 plus 1 by s. But what is important is x1s, okay, will have something divided by s minus 2. Okay, and this s minus 2, okay, this s minus 2 corresponds to e power 2t term. Okay, e power 2t, this is what is unbounded, because for t tending to infinity, okay, t tending to infinity, it will grow. So this at least one state is unbounded. But similarly, if you did the similar analysis for LHP pole, let's not repeat the calculation. Okay, what you are going to get x2s na will be some function and upon s plus 2, and this s plus 2 corresponds to e power minus 2t, which is a bounded exponential signal. Okay, here the output will be bounded. Okay, so now let's read the option. Now let's read the option. Third is a pole at origin. So, you know, for some bounded inputs, it may be stable also, it may be unstable also, but have a look into the option. There exists a bounded input such that the signals all are unbounded? No. Okay, not all are unbounded. The signals x1, x2, x3 are unbounded for all bounded inputs. This looks like same option only. The signals x1, x2, x3 are bounded? No, not all are bounded. There exists a bounded input such that at least one of them is unbounded. Correct. That's what I have shown you. At least one of them, but not all. But at least one of them is unbounded. Option number 4. At least one of them is unbounded. That is option number 4. Okay, dear? Yes. Right. Just wait a minute now. These are my questions done. Just hold on. Just hold on, hold on. Okay, dear. So this is one question: communication or maths, anywhere you place, that is one and the same thing. Okay, so answer I just discussed, it is going to be 7. Okay, so let's not again discuss this. The next question, sir.
Yeah. Sir, this is one question. So this is one question which was similar to one of the previous questions, sir.
Okay. Yeah, joint PMF.
Yeah. So MY sir has sent the solutions. I'm just explaining the solutions on behalf of MY.
Because right now MY sir is not here in the studio, but at least some 4 or 5 communication questions that also we are doing.
Yeah.
I think then sir majorly EC paper is discussed. Some 55
So,
50 questions easily.
This question a lot many people are doing by using the formula, not a correct and suggested approach. Okay. So for this question we have x, x is 0, x is 1, and then we have y is 0 and y is 1. Okay, and the probabilities are given for each of these. X0, y0 probability is nothing but 0.06. Okay, and x0, y1 probability is 0.14. This is 0.14, and x1, y0 probability is 0.24, and then lastly x1, y1 probability is 0.56. Okay, so what is the probability of x0? Probability of x0 from this probability of x equal to 0 is equal to 0.06 plus 0.14, which is 0.2. And what is the probability that x is equal to 1? So this is 0.24 plus 0.56, which is 0.8. And furthermore, what is the probability that y is equal to 0? Probability that y is equal to 0 is 0.06 plus 0.24, which is 0.3. And what is probability that y is equal to 1? That is nothing but 0.14 plus 0.56, which is 0.7. Okay, 0.7. So this is the very first thing you are supposed to do, no matter what. Even if you are using the formula, you are supposed to find out the same thing. Next, verify one thing first. That is whether the x and y random variables are independent or not. How to verify that? For that, you can verify. Let's assume what is the probability that x equal to 0 and y equal to 0. You can cross verify that this is nothing but product of p of x equal to 0 as well as p of y equal to 0. 0.3 into this is p of x equal to 0 into p of y is equal to 0, which becomes equal to 0.2 times 0.3, which is equal to how much? 0.06. And that is true for rest all cases also. For example, what is the probability that x equal to 0, y equal to 1? It is a product of y equal to 1, 0.7, and x equal to 0, 0.2, which is nothing but product 0.2 into 0.7 is nothing but 0.14, and so on. What is the probability that x equal to 1, y equal to 1? It is nothing but a product of p of x equal to 1 as well as p of y equal to 1. 0.8 into 0.7 is nothing but 0.56, and so on. What is the probability that x equal to 1 as well as y equal to 1? This becomes equal to probability of x equal to 1 into probability of y is equal to 1. Okay, which is equal to 0.7 into 0.8, which is equal to 0.56. So in general, you can say that in general, the probability of capital X is equal to small x as well as capital Y is equal to small y is equal to probability of capital X equal to small x into probability of capital Y is equal to small y. So whenever this condition is satisfied, we can say that the random variables are independent. Okay, random variables are independent. And whenever random variables are independent, mutual information is 0. Common sense, right? So when the variables are independent, there is no mutual information between both of the variables. Okay, so when they are independent, so in this case, mutual information is nothing but 0. So this is one of the properties of the independent random variables. Whenever we have independent random variables, the mutual information is nothing but 0. So that is what I of xy. So answer is nothing but in this case 0. Simple question. Okay. Logically, if you solve, it's a very simple question. So first of all, verify whether the variables are independent or not. If the variables are independent, answer is nothing but 0. If the variables are not independent, only then you are supposed to use the formula, get the answer. Okay. Yeah. So this is another question given to us. So we have random variables taking values of -1, 0, 1, and the probability of x being equal to -1 is also equal to probability of x being equal to 1, which is nothing but alpha, and probability of x being 0 is nothing but 1 minus 2 alpha. This is a value, and we have been given that alpha lies in the range of 0 and half. Okay, so then you have been given some 4 options and you are supposed to find out which of these options are correct. Okay. See, the question is pretty simple if you go by logic again. So here, when will the symbols be equiprobable? Okay. Equiprobability happens whenever alpha is equal to 1 minus 2 alpha. So that is the probability of x equal to minus 1 is same as probability of x equal to plus 1 is same as probability of x equal to 0. So this is the condition. On the basis of this, we get alpha being equal to 1 by 3. Okay, 1 by 3. So this is the condition for equiprobable scenario. Okay, so this is nothing but the condition for equiprobable symbols. The moment you understand this, now from this step onwards, it's all logical now. Okay, so we all know that the graph of entropy with respect to alpha in this case will be a graph which is inverted U graph. Okay, so this is the plot of h of alpha with respect to alpha. Okay, and the peak occurs when, in this case, whenever alpha is nothing but 1 by 3, because whenever the symbols are equiprobable, so in this case entropy is nothing but maximum. Entropy is nothing but maximum whenever the symbols are equiprobable. See, that is what is expected from you by the examiner also. 1 by 3 is how much? This is nothing but 0.33 and so on, 0.333. Now let's verify. Okay, now we have to find out the relative values between all these guys. Okay, one we have is 0.4. 0.4 is how much distance away from 0.33? I think 0.7, nearly 0.07 you can say. So somewhere here now you will have, okay, so somewhere here you have 0.4. So this point corresponds to how much now? This is g of 0.4. Okay, how much is the distance between these two values? That is the first value of alpha as well as the second value of alpha. It is nearly you can say close to 0.07. Okay, this is for the first comparison. Second one is 0.3. 0.3 is somewhere here, right? Okay, so this is nothing but 0.3. So how much is this distance? This is nearly 0.33 minus 0.3 is nearly 0.03. So which is closer to the maxima? Closer to the maxima is nothing but g of 0.3. So this point here from graph you can say is nothing but g of 0.3. So now from this you have the first answer. You can clearly see ki g of 0.3 will be definitely greater than g of 0.4 because 0.3 is closer to 0.33 as compared to 0.4. Whoever is closer will have the largest value, right? So since g of 0.3 is closer to 0.33, definitely g of 0.3 will be larger than g of 0.4. So means D is definitely correct. One correct answer. Next, similarly, we'll draw one more graph to understand the second answer. Okay. Again, same thing. I am taking h of alpha or g of alpha in this case as a function of alpha. We'll get inverted U graph. The maxima occurs whenever alpha is nothing but 1 by 3, which is nearly 0.33. Next, the second numbers are 0.25 and 0.3. Okay, the second two numbers are 0.25 and 0.3. So here is where we have 0.3 and here is where we have 0.25. In this case there is no context. Okay, there is no context here. Clearly we can see ki g of 0.3 will be larger than g of 0.25 from the graph. I am not doing any calculations here. I am simply logically analyzing this question to get the answer. Okay, so this value will be definitely, this is g of 0.3. The only calculation I have done was this only. To find out the value of alpha, the condition for equiprobable scenario, which will relate to the maximum value of entropy. Okay, and this is now g of 0.25. Now amongst g of 0.25 and g of 0.3, which is larger again? G of 0.3 is larger. So where do we have that option? So g of 0.3 is greater than g of 0.25. That's it. So the correct answer in this case is nothing but we have two correct answers, B and D. This is a MSQ question. Okay, it was a 2-mark MSQ question by the way. Okay, yeah. Next we have this question. So here we have been given a FM signal, and obviously this is the narrowband FM signal, and you are supposed to find out the peak frequency deviation. Okay, so what is the frequency of the FM signal? The f as a function is nothing but this is d theta by dt, right? Okay, in fact 1 by 2 pi d theta by dt. When you differentiate this with respect to time, what do we get now? Divide that also with respect to 1 by 2 pi, you get this as nothing but fc plus, what about the remaining term? If you differentiate sine, we get cos, so 3 into 2 pi f1 will come out, but 2 pi and 2 pi is gone, so 3 times f1, okay, and then you are having cos of 2 pi f1t plus, so here we have 4 into, this is 4 into, differentiation of sine is again cos, differentiation of 6 pi f1t with respect to t is nothing but 6 pi f1, 6 pi by 2 pi is how much? This is nothing but 3. So 4 into 3 into f2, by the way this is f2, I'm sorry, this is also f1, I'm sorry, this is also f1, into cos of 6 pi f2t. Okay, and we want to find out what is the maximum frequency deviation. So this is fc, whatever this value that you see is nothing but this is frequency deviation. So we have to find out the maximum of this function. Okay, when will this function be maximum? Whenever t is nothing but 0. So at t equal to 0, we get del f max, and the maximum frequency deviation becomes equal to how much? The coefficient here is 3f1, so this is 3f1 plus, here we have 4 into 3, 12 f1. Okay, and by the way this is f1, in both cases it is nothing but f1. Okay, and 3 plus 12 is nothing but 15 f1. This was a MCQ question, and in this case the correct answer is nothing but 15 f1. This is the maximum frequency deviation we are having in case of this FM signal, right? Yeah. Yeah. So this is another question. This is, again, I believe if I'm not wrong, this was MSQ question, right? This is MSQ question. So here, when can we use envelope detector? Here also we have envelope detector for demodulation purpose. So here also this is for demodulation purpose. Okay. So the condition for envelope detector to be used in case of DSB signal is nothing but m of t has to be greater than 0. So this is definitely a correct statement. Okay. This is definitely a correct statement. So statement 1 is correct. So statement 1 is true. This is one of the correct answers. But if you notice, statement 2 is not correct. Why? Statement 2 is not correct because of the fact of this particular word only. Okay, here this guy said that envelope detector can be used in EM scheme only whenever m of t is greater than 0, which is a wrong statement. Okay, we can use envelope detector also by means of modulation index. Okay, so whenever if you satisfy the condition of modulation index, also we can use envelope detector, but not just by using by having the fact that m of t is greater than 0. So because of this, this statement becomes wrong. Okay, so means statement 2 is false. 2 is false. This is also correct statement. So we have two correct answers here. Some people will not notice this particular phrase only, so because of which they may do this question a bit wrong, but rather this part is very, very important for you. Okay, there are two ways by which we can use envelope detector for demodulation in case of AM signal. One is, this is one of the condition, not the only condition. Okay, this is not just the only condition for using envelope detector in demodulating AM signal. Okay, so these are some of the questions we have in communications that we have got. Okay, so with this, I think we can close this session. Okay, we have discussed quite a good number of questions, just like electrical paper. I think we have covered nearly 55 plus questions in this particular session. Okay. So with this we'll close this session. Any more questions you have, please post it in the comments so that we will provide solutions for all of them, maybe tomorrow. Okay, in tomorrow's session probably we can upload the solution separately for you. But if you have any other questions, you can always post it in the comments or you can post it in the Telegram group so that we can give you solutions for those questions. Okay. Yeah. So thank you all for joining the session and making the session a success. Okay. Yeah. Yeah. Guys, there are a couple of more questions that were raised. One is musical chair question in aptitude. I have solved this question in exam, but rather mostly marks to all. Okay. There is a very good chance that for this question, it will be marks to all. Okay. Right. So I think Pratyusha was asking this question. I hope your doubt is answered. Mostly for this question, it will be marks to all. Okay. And again, there was one more question. Yeah, on the basis of, was it on bandwidth or SNR? I don't remember. Graph of channel capacity with respect to bandwidth. I don't remember that question. I think I have to go through that question once again. Okay. I don't remember that question exactly, Aditya. Was it a question between channel capacity versus bandwidth or channel capacity versus SNR? If you can give me the clarity, I'll be. But rather, I don't remember the question exactly. Okay. If it is channel capacity versus bandwidth, it will be a straight line mostly. Okay. It will be a straight line mostly. Because what is the formula for channel capacity? So the channel capacity is given by bandwidth times log of 1 plus SNR base 2, right? So accordingly, we have a direct proportional relation. Channel capacity is proportional to bandwidth. So in this case, the plot will be straight line. If it is the plot between channel capacity as well as bandwidth, okay, it will be a straight line graph because we have a proportionality as long as SNR remains constant. Assuming SNR remains constant, the graph between channel capacity and bandwidth will be a straight line. Okay, if it is like I've told, the graph between channel capacity and bandwidth. Okay, again, I don't remember the question exactly for this specific one. Okay. It's 3, 9, 19 series. There is no 3, 9, 19 series question, guys. Again, I'm not communications faculty. This is my understanding. Okay, this is my understanding. I may be wrong. Probably that is in the morning session, guys. There's also morning session that could be in the morning session. Again, like I've told, my understanding of communications is limited. I'm assuming this could be the answer on the basis of my knowledge. Again, I'll talk to Ijaz sir, MY sir, and I'll get back to the solution. Get back to you with the solution. Okay. Okay. I think this is it for this question. Is definitely again, this is I'm 100% or I can't 100% sure, but though I'm 95% sure that this will be marks to all. Okay. This musical chair question will be a marks to all question. Right. Okay, guys. With this, we'll call it a day. Thank you.